A warm welcome to all the participants who have joined for this workshop on primer in SPSS data analytics organized by the Academy of the StatCom. I humbly request all the participants to please put your mic on so that we could go on with the workshop without any hindrance. Okay. So just a brief intro about the StatCom. So StatCom is the Tamil Nadu Alliance for Development of Community Medicine. So it is an association and it is officially registered body. And since its inception, that is in the last year from May 2023, we have been organizing various events. Even we have organized an international conference in Ooty in the month of January this year. And we keep on conducting various workshops, both offline as well as online. And I hope this is nearly our 10th or 12th online workshop that we are doing from StatCom. And we also have an official journal of StatCom, that is International Journal of Preventative and Evidence-Based Medicine. And the journal has published nearly 2 issues so far. And we will be soon moving to the DOAJ indexing and further indexing and all. We are planning to move further. And we have a membership for StatCom. And if you are interested, either the postgraduates or faculties can also take this membership, so that you will be getting various benefits, and also the fee waiver in various workshops and all will be there. So with this brief intro, I would like to invite our first speaker, Josephine Priya ma'am, for this introductory session. And before small introduction about Josephine ma'am. Ma'am has done his MBBS from the from the St. John's Medical College, Bangalore, and has done her post graduation in community medicine from the Bangalore Medical College and Research Institute. And she is currently working as an associate professor and is the HOD in charge of the Tanjavur Government Medical College. And previously, she has worked in the government Trichy Medical College as assistant professor and all. And her areas of interest include medical research and medical education, epidemiology, and non-communicable diseases. So, with this small intro, I would like to invite Josephine Priya ma'am to kindly take over from here.
Yes, thank you. Thank you for that introduction. So I think we have a good number of participants online already. So good morning from me to all of you. And I'm having a little bit of a sore throat going on. So if I'm soft or not audible, please let me know. So we are starting our first session today, and I hope all of you have joined us after a good breakfast. And I hope your baseline knowledge levels improve significantly at the end of this one-day course on SPSS, and you are more confident in undertaking medical research. So quickly moving on to our session. So our first session is going to be about all the various different types of data, how data is going to be distributed, what is a hypothesis, what that hypothesis means, how you arrive at a null hypothesis, an alternative hypothesis, how you test it, what is p-value. So this is like a start to your course. And I'm going to keep it simple. I'm going to teach only the things that are relevant. At the end of the day, we are not becoming statisticians. We are going to be medical researchers. So I'm going to keep it relevant to what we will need in our research. So shall I start sharing my screen now?
Yes, ma'am, please.
So I have one request. So kindly, during the course of the session, let us all keep our mics on mute. I will be asking some questions, and that time maybe we can unmute and participate in the discussion. So that will make it more interesting for all of us. Right. So, like I told you, we are going to talk about types of data, data distribution, hypothesis framing, and testing. So I always like to start with how we are all so scared of research and how nobody really understands what research is. So here we have a person who says, I didn't have any accurate numbers, so I just made this one up. And there are studies that are saying that accurate numbers are not more useful than what we make up. And somebody asked him, so how many studies said that? So he says 87. And I think we can guess about whether that is a real study or it is just made up. So what do I want you all to know at the end of this session? Okay, so I have some simple objectives. So I want that at the end of this 45 minutes, all of us will be able to identify and differentiate the different types of data that we are going to come across. We should be able to describe and interpret the distribution of our data, and we should be able to formulate a research hypothesis and also think of how we are going to test that hypothesis. So coming to the first thing, we keep talking about data. So what actually is data? So data is nothing but all the information that we are collecting over time. Okay, so this information, they are just pieces. Okay, so I call them building blocks of knowledge. So it's raw information, they're all pieces, and we cannot really get any significant information from this. What we need to do is you need to put it together. You need to apply statistical methods. You need to apply scientific process. You have to analyze this data and interpret it, and that interpretation is the scientific information that we derive at the end. So commonly you'll come across many words. You'll hear words like qualitative variables, quantitative variables, categorical, and there are many other terms. So now we are just going to look at the different types of data in medical biostatistics so that we understand what these terms mean. So broadly, you can say that there are qualitative variables and quantitative variables. Now, qualitative variables, these are more like naming terms, okay? So if I'm asking what is the gender of an individual, if I'm asking what is the educational status of the individual, if I'm asking if a person is coming from a rural or an urban background. So all these questions, the answers are going to come in the form of names, male or female, urban or rural, educated or not educated. So these kind of variables are qualitative variables. They cannot be measured quantitatively, and they are identified in terms of names or categories. So like I told you, examples will be place of birth, ethnic group, even the stage of cancer. So is this person having stage 1 cancer, stage 2 cancer? So even though you're looking at a number here, it is actually just a category. Okay, you have categorized the stage of cancer. degree of pain. So I either give a visual analog scale, or I ask him to tell me, you don't have pain, or it's minimal pain, moderate pain, severe pain. So we are categorizing. So all these are qualitative variables. Now, qualitative variables are also called categorical variables. So the term qualitative and categorical, they refer to the same thing. Then we have quantitative variables. So these are what are being measured, and it is expressed numerically. So if I'm asking questions like how many, how much, how often, so how many children does a person have? How many episodes of diarrhea occurred to this child? Or how many times have you vomited in the last 2-3 days? So these kind of questions, we are taking measurements. Okay, so these are quantitative variables. Now, quantitative variables can be discrete or continuous. Discrete is a specific digit. Okay, so you have a whole number value to it. If I ask a woman, how many children do you have? She can only tell me 0 or 2 or 4. Okay, so she's not going to be able to tell me that she has 2.6 children. So it cannot take decimal points. Whereas continuous variables, they follow a continuous scale. Okay, so I can measure height of an individual. The height can be 161.4 centimeters, or the weight can be 55.3 kg. So these kind of measurements are continuous variables. So this is one kind of classification. The other classification is called scales of, one second, my PPT is not, yeah. So the other classification is called scales of measurement. Now, this is another common thing to understand your data better. So we say there are 4 scales. So I'm going to go from bottom up. If you look at the picture, so I start with nominal data. So nominal means named. Okay, so here it is named data. For example, gender. So it has a name. It's either male or female or others. Or place of residence, rural, urban, semi-urban. So these are all nominal data, which are categories, but there is no inherent order to the data. What I mean is the next classification is the ordinal data. So this is also, they have names, but there is an inbuilt order to these data. For example, what is your rank in class? Okay, so I asked 10 children. So one child is rank 2, one child is rank 5, one child is rank 6. You know that you can place it. So there is an order or a direction to this data. Now, nominal and ordinal data both come under qualitative formats. Okay, then moving on to interval and ratio data. These are quantitative formats. And interval data is one where you take measurements and you know that the distance between two measurements is, you can understand it and it remains the same. For example, if I'm sitting in Tamil Nadu and the temperature is 40 degrees, and in some other state, the average temperature is 30 degrees, this difference of 10 degrees will be the same even if the temperature is 20 degrees or 30 degrees. So that interval remains the same, but there's no absolute zero. Ratio data, on the other hand, is the same. There is an interval, but there is an absolute zero. So we can take a look at this if you've still not understood. Nominal data, they are categories or names. There is no implied order among the categories. The individuals will be placed in proper category, and the and the count for each category is determined. What it means is, for this kind of data, we can only take a proportion. We can say so much percentage of my study population were males and this percentage were females. So that's what we mean by count. Moving on to ordinal data. So ordinal data has an inherent order. So you have an interval. The interval need not necessarily be equal. If it is represented by numbers, the numbers only show a sequence. It is not it's not quantitative. So we are not able, you should not use it to find means or, medians and things like that. What it means is, if I'm taking ranks, request you all to please mute your mics. Okay, so if I'm taking the rank of students, so even though I have a number there that says first, second, or third, okay, these are only representative of position. This number is not, definitely not quantitative, and we should not be using it to do arithmetic. So on, similarly with, the stage of cancer. So examples of ordinal data, economic status, okay, whether they are of low or medium or high economic status. If you're grading test papers, right. Next is interval data. So somebody with the name of iPhone has your mic open. Can you please close it? Okay, next coming on to interval data. So these are numerical data, okay? The interval between these data are going to be equal, but there is no clear zero. So what example will be temperature. So like I already explained, the difference between 10 degrees and 20 degrees is going to be the same as the difference between 30 degrees and 40 degrees. So also with time. So we don't really have a starting point saying 0 o'clock, right? So time, the interval remains the same. We don't have a starting zero. But when we go to ratio data, you can make meaningful ratios using these data because it has a true zero starting point. For example, temperature on the Kelvin scale. So it does have a zero. Age, okay, so 10 years, 20 years, 30 years, time interval measurements, weight measurements, all these have a true 0 point and they qualify as ratio data. So we looked at quantitative and qualitative. We looked at scales of measurement where we have 4 scales. Now there are 2 other terms that we commonly use and it is very useful when we are doing our analysis in SPSS. So that is called a dependent variable and an independent variable. Okay, so what is a dependent variable? What is an independent variable? Now, when you're conducting a study, okay, you are going to have a risk factor or a cause, and you're going to see what effect it has on an outcome, right? So these are 2 separate variables. Now, this, for example, let me take the example of smoking and lung cancer. So I want to see whether cigarette smoking has any effect on the outcome, which is lung cancer, right? So lung cancer is dependent or not dependent on the smoking. So we are manipulating the smoking variable. So what happens is lung cancer or the outcome variable that we are looking at is a dependent variable. So this dependent variable changes as a result of manipulation of an independent variable. The independent variable is what we call the risk factor or the cause. Okay, so dependent variable is a variable that changes as a result of manipulation of the independent variable. Dependent variable is the outcome that we are interested in measuring because it depends on our independent variable. We also call it the outcome variable or the response variable. We call it a left-hand side variable because in regression equations, it comes on the left-hand side. Coming to the independent variable, this independent variable is what we call a cause or a risk factor. Okay, it is independent of other variables in our study. So to understand it better so that you don't get confused, let's quickly look at an example. Okay, so I've taken a very simple example, a non-medical example. I want to see, okay, I have a doubt. If I modify the amount of water that I'm putting for the plant and the amount of fertilizer I'm adding to a plant, is it going to affect the growth of the plant? Can you all just quickly take off your mute and tell me what you think is the dependent variable and which is the independent variable? What am I manipulating? Anyone?
Independent variable is the growth of the plant,
Okay.
whereas the dependent,
How many dependent variables do I have here?
the growth of the plant will be dependent variable, whereas the watering of
Yes.
plant and the fertilizer amount is the
Yes.
independent variable.
Yes. So my outcome depends on the risk factor, right? So my outcome is always a dependent variable. The outcome I'm looking at over here is the growth of the plant. So like you rightly said, the dependent variable is the growth of the plant. Whereas what am I checking? What are my risk factors? Okay, so or what is the exposure that I'm assigning? So I am modifying, manipulating amount of water that I'm giving and the amount of fertilizer I'm giving. These are independent variables, right? What I am manipulating. So this becomes the independent variable. Is this clear? Do you want me to explain this one more time? Because it is very important that everybody understands the concept of dependent and independent variable. Shall we go ahead? I have another example that you all can try. So I want all of you to try this. Hopefully you all have a piece of paper and a pen at hand. I have 2 research questions. I want you all to quickly write down what you think is the independent variable and what is the dependent variable. So when I give the answer, you all can check. So my first research question is, what would be the effect of intermittent fasting on blood sugar levels? Can you all quickly just write down what is the independent variable and the dependent variable here? Right. And my second question is, will music have any effect on anxiety reduction in patients with chronic anxiety? Shall we discuss the answers? You all can even put it in the chat box. Just quickly put down in the chat box what would be the independent variable in both cases and what is the dependent variable in both cases. The easiest way to remember is the outcome or the disease, okay, will always be the dependent variable because it is dependent on the risk factor. So I can see that many of you are getting the right answer. There are also some wrong answers there. So Adyasha says music is the independent variable, anxiety is the dependent variable. You're right. Sadaf, blood sugar levels are dependent. Yes. So, okay, so I think you all have understood. So I'll just quickly put down the answer and you all can check your answers. Right? So for intermittent fasting, so what am I manipulating? I'm manipulating the fasting. So I have a group that does the intermittent fasting and a group that doesn't have the intermittent fasting. So this is my risk factor or my exposure status. So this is the independent variable. What is the outcome? The change in the blood sugar levels, that's my outcome. That becomes the dependent variable. For music, so I have one group where I am going to give music, the other group I'm not going to give music, and I'm going to measure the anxiety levels. So the outcome is the anxiety, that becomes the dependent variable, and the presence or absence of music becomes the independent variable. I hope now you all have a good idea of what an independent and dependent variable are. Yes? Right. So with this, I have completed all the different types of variables. Okay. You can still come across some names. Okay. But this is the basic concept of how we classify all our variables. And once you understand this, you should not have any difficulty in deciding what kind of variable you're dealing with. Now, what happens is we collect a lot of data. Okay, different kinds of data. Okay, and I want to see the spread of my data. Okay, so I have collected the age of 100 children. Okay, and I want to see how. So I have a sample population. So I randomly selected 100 children from a school, and I have taken certain information. I want to see how the age is distributed. Are they all around the central zone, or are they very dispersed? So when I spread this data, okay, that is what is called a distribution. Now, the types of distribution, there are numerous types. Okay, so for continuous variables, we have some distribution. For discrete variables, we have some. And each of this, it can give you a lot of information, but at the beginner level, it can also be confusing. So what I want all participants today to focus on is the ability to identify a normal distribution, because when we use SPSS and when we are analyzing, we need to make a decision of using either parametric or non-parametric tests. So we will have a question and we want to find an answer to that question. Okay, so firstly, you need to know what is the statistical test you want to do to arrive at that answer. And when you know that, depending on your data distribution, you should be able to decide whether that question is going to be answered by using a parametric test or a non-parametric test. If your data follows a normal distribution, we will opt for parametric tests. If it follows a non-normal distribution, we opt for non-parametric tests. So I'm not going to confuse you with various kinds of distribution. The normal distribution will be covered in detail in a subsequent session. So I'm just going to introduce you. I'm going to leave you with this picture of what a normal distribution looks like. So if you look at the right, you have a nice bell-shaped curve, right? So we traditionally call it a bell-shaped curve. It will be symmetrical. So if you fold this curve on itself, okay, both halves will coincide. And that happens because the mean, median, and mode will be right at the center and they will be at the same point. So we say the mean is equal to the median, which is equal to the mode. So this is a normal distribution. You have many other types of distributions, and maybe at a later date, you could go through it. So for today, let's focus on a normal distribution. Coming to the term hypothesis. So we keep saying hypothesis. At the end of today's session, hopefully you have a better idea of what hypothesis is, what is a null hypothesis, what is an alternative hypothesis. So a hypothesis is nothing but I introduce two terms to you. That is an independent variable and a dependent variable, right? When I state a relationship between these two variables, that X can cause this change in Y, okay? So when I state a relationship between my independent and the dependent variable, that is what I call a hypothesis. But I cannot blindly state a relationship. It should be based in scientific knowledge. So a hypothesis is a testable statement that will explain what is happening or what is being observed. It is a relationship between the various participating variables. It should be based on existing theories and knowledge. So the main point about a hypothesis is we should be able to subject it to scientific testing. You should be able to build a scientific experiment. You should be able to collect data, make observations, collect that data, analyze it, and at the end, you carry out a statistical test. You calculate that statistic value, test value. You calculate a p-value, and then you finally decide whether your hypothesis is right or not right. This is a hypothesis. So I will always give examples. So I have a research question. Okay, my question is, what could be the impact of maternal smoking during pregnancy on the birth weight as well as the gestational age of the newborn child? Okay, can we quickly just try formulating a hypothesis? So you're going in a little blind right now, okay? But I want you to try to formulate a hypothesis so that in the next example, you're able to refine your hypothesis framing. Can you all quickly formulate a hypothesis? You can put it in the chat box also. So like I told you, a hypothesis, we do not just think and we don't just formulate any random statement associating the independent and the dependent variable. It should be based on some review of scientific literature. So what do you think is the hypothesis here? Anyone? Would you all like to unmute and give me an example of what you think will be the hypothesis here? No?
Hypothesis, maternal smoking has an impact on birth weight and gestational age of newborn.
Right. Okay, that is one hypothesis. So good. So okay, there is Dr. Pratiksha who says there's no relationship between maternal smoking and birth weight. So all these are hypotheses. Yes, I agree. Anything else? So you can have numerous hypotheses. Depends on our review of scientific literature. So what I'm doing here is I have just framed a simple hypothesis. Okay, I'm saying maternal smoking during pregnancy is associated with lower birth weight and shorter gestational age. This is what I got after review of scientific literature. Okay, but now I want to take you one step further and I want to teach you how to frame the null hypothesis and the alternative hypothesis, right? So in statistics, okay, our starting point for any hypothesis testing is from the null hypothesis. Null means no. Okay, so we always start with there is no difference, okay, or there is no association, or the groups are not different. This is what we mean by null hypothesis. So null hypothesis is the default position that there is no association between the variables. So if I'm looking at maternal smoking and I'm looking at birth weight of the newborn, my null hypothesis is that there's no association. Okay, the null hypothesis is written as H0, whereas the alternative hypothesis can be designated as H1 or HA. Okay, so if I take my same research question, my null hypothesis would be maternal smoking during pregnancy has no effect on birth weight and gestational age of newborns. But I should also prepare my alternative hypothesis because I don't know whether my experiment is going to prove or disprove my null hypothesis. So my alternative hypothesis, again, based on scientific review of literature, is maternal smoking during pregnancy will be associated with lower birth weight and shorter gestational age of newborns. Is this clear? Have you all understood the concept of null hypothesis and alternative hypothesis? Can you all take off your mics and let me know? Have you understood this? Because it's very important. This is the core for you to... Yes?
Can you explain again?
Okay, null hypothesis is our starting point is that there is no relationship. Okay, no matter what your question is, there is no relationship. That is the null hypothesis. We will also generate an alternate hypothesis that will state a relationship. Okay, so you need not even be as specific as saying it is associated with lower birth weight or shorter gestational age. So your null hypothesis can state that there is no relationship between your exposure and outcome variable. Your alternative hypothesis can state that there is a relationship, okay, between your exposure variable and the outcome variable. This is all is null and alternate hypothesis. So no relationship versus there is a relationship. Is this clear? We'll have more examples, you all can try it out. So when I want to test a hypothesis, so once I have built a null so I have a research question. My first null hypothesis states no relationship. My alternate hypothesis says there is a relationship. Now I'm going to conduct an experiment that is going to tell me whether my null hypothesis is true or not true. So not true meaning the alternate hypothesis can be accepted. Okay, so what are the steps? So first is I identify the population that I want to work with. So in my question, it will be all antenatal mothers, who are smoking. And so my population refers to all of them to whom I will make inferences. So I've got some results. I will apply that inference to that entire population of smoking antenatal mothers. My sample refers to the people on whom I'm going to do the experiment or I'm going to collect data from. So from the population, I select a specific group from whom I collect my data and I call them my sample. Okay. Then I state my hypothesis. Like I told you, my null hypothesis is maternal smoking in antenatal mothers has no effect on birth weight and gestational age. Okay. My alternate hypothesis is maternal smoking in antenatal mothers has an effect on gestational age and birth weight of the newborn. That is all. So I state my null hypothesis and my alternate hypothesis. Then I state there are certain assumptions and check conditions that we have to do during the course of conducting our scientific experiment to ensure that whatever inferences we make are going to be valid. So some of those assumptions will be that we have randomly sampled. We have not picked antenatal smoking women who are our friends, or the first few people that walk into the OPD. All these things are going to bring in bias. My risk factors should not be interacting with each other. They should be independent. Okay. Then my data also should be normally distributed. So like this, I'm going to have numerous inbuilt assumptions and check conditions. Then I'm going to calculate. So like by the end of today, you will know which test you're going to do where. So you will know what test statistic you're doing. SPSS is going to do it for you. It's going to give you the test statistic. It is also going to give you the p-value, and based on the p-value, you're going to make a conclusion. So this is how you do this. Okay. So I am going to go back. I'm going to reinforce what I've taught you using the example of the rabbit and the tortoise. Okay, so we have all heard this story in our childhood. No, there was a race between a rabbit and a tortoise, and then who came first? Okay, so now we feel that maybe the rabbit was good dressed is important. So maybe it is not a good experiment. If he had run, the rabbit would have won, right? So let us redo this experiment. Okay, if I actually want to see who should be winning the race. Okay, so my question. Okay, so p values are hard to understand. Okay, so we will conduct a trial to answer a question of who is faster. Is it the rabbit or the tortoise? So what kind of experiment will I design? Okay, so I collect a sample. So let's say I pick 100 rabbits, 50 rabbits, 50 tortoises. Okay, and I make them run. I measure their highest speeds. What is the maximum speed they attain? Okay, so this is my experiment. What will be the null hypothesis here? Can you all try again? What do you think will be the null hypothesis for this experiment where I want to see who is faster? Can we take off the mic and try? What will be the null hypothesis? Anyone? My question is, who would be faster? Is it the rabbit or the tortoise? What will be my null hypothesis?
Nobody is faster, both are equal.
Yeah, so I will say that the speeds of both are the same. That is the null hypothesis. What will be the alternate hypothesis?
They are not equal.
To speed of the
Yes, so the speeds are
Rabbit is faster.
different. Yes, so I am simply going to say that the speeds are going to be different for both of them. I don't know which is better. Yes, so my null hypothesis is that there is no difference in their speeds. They are both going to be the same. My alternate hypothesis is that their speeds, their top speeds are going to be different. So I actually conduct the study, okay? And then I measure their average top speeds. And then, so what am I going to do? I'm going to get a mean average top speed for the tortoise and a mean average top speed for the rabbit. And then it's not just enough. I can't just look at this observation and say that this is better. I have to do a statistical test, which I'm sure you all are all aware of by now. Okay, so I want to compare the two means. Okay, so I'm not going to go into the details of what test we do. And then I get a p-value. And based on that p-value, I'm going to say whether, I have to accept my null hypothesis or I reject my null hypothesis. Okay, so what happens here is, here we come across two terms called alpha and p-value. So what happens is, alpha is what we set at the start of our experiment. Okay, so when I'm starting a study, I decide that my alpha is 5%. Alpha is nothing but it's like a barrier. Okay, I'm going to say that this much is what I will consider as significant. So normally we take it as alpha as 0.05, which is nothing but 5%. What we are actually trying to say is, okay, we are going to allow random chance occurrence of only 5%. Okay, so whatever result we get, okay, from our experiment, we have to account for some probability that it can occur by random chance also, not just because of our exposure status, right? So that I cap at 5%. More than 5%, I will not accept. Okay, so random chance can be only 5%. From this, we get a p-value. P is nothing but probability. Okay, so the p ranges from 0 to 1. Okay, what it means is, so you have always heard, right? Or whether we understand statistics or not, we know that p less than 0.05 is significant. Yes, what it means is, if your finding is less than 0.05, then it means that the chance of it occurring by random chance is less than 5%. Okay, so it is a good study. Whatever finding you have come across is a significant finding, because the chance of it occurring by fluke or by luck is less than 5%. So we will accept. So it is the probability of something happening by random chance is less than 5%. Then we say it is significant. I hope this much you have understood. You need not go into the depth or the details of it. Just understand that alpha is set at 0.05 and p actually refers to the probability. You will be able to interpret your results. So,
Ma'am, can you repeat once more this p-value and alpha?
yeah. This slide will also give you a better example. Okay, so what I'm doing here is, okay, so if I want to investigate a new treatment, okay, I want to, let me say I have a drug for hypertension, okay, and I'm giving one group the drug and the other group I'm giving standard treatment, okay, and I'm finding some reduction in BP in the group that is receiving the new drug, right? And I calculate, I run the tests and I get a p-value of, let's say, 0.03. Okay, are you clear? So my experiment is, I have a new drug for hypertension and I have another group that I'm giving the standard treatment. The outcome measurement is BP. I have found a reduction in BP in the group that is receiving the new drug. I have subjected it to statistical tests. I'm getting a p-value of 0.03. At the start of my experiment, I decided that I will allow an error of only 5%. I can also decide that I will allow an error of only 1%. Okay. That means 99% I have tightened my study, only 1% error. There, the strength of your results will be much higher, but you will face a lot of practical difficulties. So traditionally, we set at 5%. Okay, so we allow our results, okay, occurring due to random chance of less than 5%.
से कोई नेता ना कंपटीशन देता है ना पढ़े लिखे हैं कुछ नहीं है ये उस दर्द को क्या समझे
Can we please mute the mic? Thank you. Okay. So this is what that 5% is. Okay. In practical situations, there may be a chance that our result is occurring random chance. Someone called Fatima Singh. Can you please mute your mic?
नंबर है उनको गवर्नमेंट कॉलेज मिलना मुश्किल है
Right. Okay. So what happens is, so we set at 95%, and that means 5%, less than 5% of the times our result can be due to random chance. So when we actually conduct the test and we get the probability of our result occurring due to random chance, P is nothing but the probability of getting our result by random chance. And when that is less than 5%, that 5% is 0.05. Okay, so if it is less than 5%, we accept that our findings are significant, because that is what we decided at the beginning, no? So less than 5% of the times, if our result can be by a random occurrence, by a fluke, by a stroke of luck, then I will accept that my results are significant. When I get P of 0.03, it means that there's only a 3% chance of my result being due to random occurrence, which is less than 5%. So I will say my finding is significant. Is this clear?
And if we set a confidence interval 99%, then we need a p-value less than 0.01.
Yes, yes.
Okay.
Yes. Okay. So roughly
Yes.
that is what
Yeah.
it translates to. Okay. So let's take a look now quickly. So does the new medication reduce blood pressure in patients with hypertension? So now we're coming to the almost to the end of our presentation about hypothesis. So let's just quickly try. Can you all quickly formulate the null hypothesis and the alternative hypothesis for this? So the null hypothesis will be that there's no difference between the two groups, both groups receiving the new drug as well as the standard treatment. The alternative hypothesis is that there will be a difference. Okay, so the new medicine will have an effect on blood pressure, and whatever difference we are seeing is not because of random chance. So I hope you all have understood the concept of null hypothesis and alternate hypothesis, right? So we perform a statistical test, we are getting 0.03. I've explained to you what this means. Okay, so to again reinforce, it means that there's a 3% chance of observing our results if the new medicine did not have an effect on the blood pressure. Did you understand? Okay. So what we do when now finally coming to the most important point, you have two hypotheses now for the same research question. You have a null hypothesis and you have an alternate hypothesis. Based on your P value, what do you do? Okay, if your P is less than 0.05, you reject your null hypothesis. Okay, so when you reject your null hypothesis that stated that both groups are the same, or there is no difference between both the groups, that stands nullified. Okay, it is cancelled. When your P is significant, the chance of your result occurring due to random occurrence is less than 5%, then we will reject the null hypothesis. We accept the alternate hypothesis that states that there is a significant difference between the two groups. This is how we draw our conclusion. Yes, so I hope you all have understood that. Now, there are certain studies where we generate hypothesis, and there are certain studies that where we test hypothesis. So generating a hypothesis states that this variable could be associated with this. Okay. Testing is you do something and you see how it is associated with it. So what are the study designs that are useful for hypothesis generation versus hypothesis testing? For hypothesis generation, no, you're merely making statements based on what you observe. You use observational studies. Whereas for hypothesis testing, you have to draw inferences. So you need analytical or experimental studies. So it's quite a simple thing to understand, but it is important that you remember that in observational studies, we are only generating hypothesis. We cannot test. Okay, we are observing something and we state a relationship between the variables. So we are generating a hypothesis. Whereas in analytical and experimental studies, we are actually trying to find out how they are associated with each other. So there we are testing a hypothesis. Now coming to this, okay, so this table is very often, I think it confuses many people. So let's try to break it down and simplify it and understand it today. So as far as your null hypothesis is concerned, okay, so when your null hypothesis is true, you should be accepting it. When it is false, you should be rejecting it. But there are some errors when we do it wrongly. So you need to understand the concept of type 1 and type 2 error. So I'm just quickly going to go through this table and then I'll give you an easy way to remember it. Okay. So first, let's look at situations where we don't make the error. So please look at the horizontal. Okay. That is my rows. Okay. So row is whether I'm rejecting or not rejecting the null hypothesis. So what I am doing as the investigator, whether I reject or I don't reject. Column is in reality, is the null hypothesis true or false? So are you with me so far? So we have a 2 by 2 table. In the columns, we have the real situation of whether a null hypothesis is really true or really false. In the rows, we have what the investigator is doing, whether the null hypothesis is rejected or not rejected. Now, two situations, there will be no issues. One, where the null hypothesis is true and the investigator does not reject it. Now, statistics, for some funny reason, they don't say reject and accept. For them, null hypothesis is everything. So we always talk in terms of the null hypothesis. We reject the null hypothesis or we don't reject the null hypothesis. Okay, that's what it means. So null hypothesis is true. The investigator has also not rejected it, meaning he has accepted it. So can you see this green square here which says correct decision? Yes? So for this discussion, can we have some feedback? Because you all need to, move along with me. So have you understood this square here, which says correct decision? Okay, the null hypothesis is true.
Yes, ma'am.
Yes, and the investigator has also not rejected. So this is no issue. Coming to this square, okay, the null hypothesis is false and the investigator has rejected it. So he is in sync, okay? So this is also a correct decision. The error comes when the null hypothesis is true, but the investigator rejects it. There we have a type 1 error, okay? This is called a false positive. I will explain it to you in a non-medical example. Okay, so that it remains, you can retain it in your long-term memory. Similarly, you have a type 2 error, okay, where your null hypothesis is false. Okay, your null hypothesis in reality is false, meaning there is a difference between the two groups. Okay, but we are not rejecting our null hypothesis. Okay, so what we are doing is we are accepting our null hypothesis. This is type 2 error. Now, in a very simple way, okay, to remember it as a table becomes confusing. I will tell you, I'll give you an easy way to remember it. So we have all seen the story of, we've heard that story of the wolf and that little boy who cried wolf. Yes, are you all aware of this story? So I'll give you a very quick recap. Okay, so there was this small little boy. Okay, the villagers asked him to take care of sheep. He was a naughty fellow. He was bored. He didn't know what to do. So he cried. He screamed, wolf, wolf. Okay. So what did the villagers do? They came running. Okay? When they came, they saw that there was no wolf.
Speaker
Yeah, so we are going to do, I need just 2 more minutes. Can we have muted mics, please? Dr. Arup. Okay, so what happened is the villagers came and they saw that there was no wolf. The boy was lying. Okay, this happened multiple times till the villagers stopped believing the boy. The last time that the boy cried wolf, wolf, there was an actual wolf, but the villagers did not come out, right? So in the last scenario, what happened? The wolf was there, but the villagers did not come. Okay, so I want you to keep the story in mind. So I'm requesting Dr. Arup, please mute your mic. I'm having to scream above that.
Ma'am, one recommendation, ma'am. Like that, there is an option in Zoom like to mute every participant.
I don't have that control. So can the coordinator please do that? Yeah, thank you. So what happens is, so remember this story, okay? The first error happened when there was no wolf, okay? The boy was lying and the villagers came out. The second error happened when there was a wolf, but the villagers were not believing this boy, so they didn't come to save him. So type 1 error is the first error, okay? For this story, the null hypothesis is that there is no wolf, okay? The null hypothesis is there is no wolf. So in the first event, what happened is when he cried wolf, there was no wolf, right? So the null hypothesis is true. Okay, the null hypothesis being that there is no wolf, but the boy said there is a wolf. He was lying. Okay, the null hypothesis was true, but the villagers responded by coming to try to save this boy, right? So that is a false positive. That is a type 1 error. What did they do? When the null hypothesis was true, they rejected it. Okay. In the second time, the null hypothesis was false. Okay, the wolf was present. The null hypothesis was false, but they did not reject the null hypothesis. They should have rejected the null hypothesis. The null hypothesis that said that there's no wolf, if they had rejected it, they would have come out to save the boy. They did not reject the null hypothesis. When the null hypothesis was false, this is type 2 error. So I hope you can remember that. Okay, so type 1 error, null hypothesis, there is no wolf. Villagers incorrectly rejected the null hypothesis and came to save the boy. This is called a false positive. Okay, so this is a false positive. In the second type of error, the null hypothesis was true. They incorrectly accepted the null hypothesis. This is a false negative. Okay, so in future, if you're confused about type 1 and type 2, just remember the errors in the order of this story and it will help you. Right, so again, to recap, the risk of committing the error is actually the significance level. So what happens is, like I told you, we set alpha at 0.05, or we are accepting a 5% error. That's what it translates to. Loosely translates to, we accept a 5% error. So the type 1 error is nothing but your alpha. Okay, the significance level is usually set at 0.05 or 5%, which means that the results only have a 5% chance of occurring if the null hypothesis is actually correct. So when your p-value is below the significant level, it means that your null hypothesis needs to be rejected and your alternative hypothesis needs to be accepted. Okay, so I have already explained this. Okay, so these are my references. So I hope you all have understood. In my second session, I'll be sharing my email. Any doubts that you have, you can email me and I will get back to you as soon as possible. Yes.
Madam, I want to ask one thing.
Yes.
Madam, as you said that the probability of the test to find a true positive denotes as 1 minus beta. It will be a power of the study also, no?
Yes, that is the power of the study. But so I don't want to confuse you all too much. Okay. So power of the study depends on many things. So if you want to increase the power of your study, your sample size needs to be good. Also, sometimes what happens, the effect size of what you're measuring, okay, smaller changes in the effect size may not get picked up. So like this, there are numerous other things. But for today, I want you all to understand this table and go back and you can read into the depth of it.
Should the null hypothesis always be about no difference?
Yes, null hypothesis is just no difference or it is the same. So null hypothesis, we start from saying that there is no difference. So I'll stop screen sharing. With this, we've come to the end of our first session. Dr. Vijay Karthikeyan. I think it's already, yeah, we've crossed the time for your next session. We've taken a little bit of extra time.
Quickly, if the participant has any doubts, you can just unmute or put in the chat box. We will have a discussion for 5 minutes or so. Then we will move on to the next session. If you have any doubt, please put it in the chat box.
What I would suggest now is the world has changed. So when we initially, started working in research, I had to open books or search online and you wouldn't be sure about the answers you're getting. And many times you would have a doubt and you don't really know where to find the answer to that. Now you have a lot of AI. Okay. A lot of times I would suggest you keep practicing. You find research questions, you read journal articles, you try formulating a hypothesis. ChatGPT helps. It is essential that you have a baseline knowledge. Okay. And when you put it into that, and you can test whether your interpretation is right or wrong. These are skills that don't just come after, just listening and, reading. You have to put it into practice and you have to keep trying, and that is how you check whether you're able to formulate a good hypothesis.
Ma'am, one doubt.
Yeah.
Age is a continuous or discrete variable?
Sorry?
Age is a discrete variable or continuous variable?
Okay, so a very simple way to find this out is discrete will be a whole number. Okay, but age, on the other hand, I can even say 3.5 years. I can even be more specific and say 4.5 years, 4.3 years, right? So then it is a continuous variable. A discrete variable will not take decimal points.
Okay, thank you, ma'am.
Madam, there is this, as you said, that is ChatGPT generated statistical analysis.
Not statistical analysis. No, I'm not talking about, yes, ChatGPT also does statistical analysis, but when you start working with it, you realize that ChatGPT also makes errors, which is why I suggest that we have a lot of help at hand, but also ensure that you know the subject so that you can pick out the errors. When you have a certain amount of understanding, ChatGPT can really help you practice.
Ma'am, can you please explain the concept of p-value once again?
Okay, see, at the end of the day, many of us, we are not statisticians. So don't try to think that you need to go down to the core and you have to understand, okay, a lot of very good medical research is carried out by people who don't understand statistics. So roughly, if you look at it, no, there is a curve, okay, and that central 95% is marked, okay, in that curve. So I want, in most cases, my results are going to come in this portion, okay. On both sides, no, on the tail, I have 2.5% on the left and 2.5% on the right. These are called critical points. An occurrence happening over there, okay. So what I am trying to say is, I decide at the start of my research how much of error I want to allow, okay. So in the scientific community, we say that we allow less than 5%, okay. So whatever finding that I get, okay, it can occur due to random occurrence or chance, not because of what I'm manipulating or what exposure I'm assigning, in less than 5% of the cases. If that happens in less than 5% of the cases, I will still consider my results as significant, okay. That is all it translates to. So that P actually stands for probability. It actually calculates the probability that your result is occurring due to random occurrence or by chance. So what it actually does is, because now all this is already set into your statistics software, right? So when I get my P as, let's say, I even get my P as, let's say, 0.02. Okay, so that 0.02 is nothing but 2%, right? So it is less than 5%. So I had set the cap at 5%. I'm saying if I will accept that my result can occur by random occurrence in less than 5% of the cases. If it is, so this P tells me that my result can happen due to random occurrence in 2% of the cases. Since it is less than 5%, I will accept my result as significant. That is all it translates into. If my P was 0.06, okay, then my result can be happening due to random occurrence in 6% of the cases. Then my study is not tight. I had decided 5%, less than 5% as the cap. So then I will say my result is not significant. I should be accepting the null hypothesis. It sounds very confusing, but as you keep working with it, you will start understanding it. So don't worry. Just keep practicing. There are lots of practice questions. Keep practicing. Keep performing analysis and try to interpret p-values. I hope it helped. I hope you could understand something.
Yes, ma'am. Thank you.
I'm just going to put down my email ID in the chat box. You are free to email me with all your doubts, and I will get back to each of you. Okay.
Hello.
Which test do we use to
Yes, yes,
calculate
ma'am.
p-value?
Yes,
There
yes,
are
ma'am.
numerous tests. Yes. I'll just get back. 1 second. So there are numerous tests. So the test varies depending on what our question is and what we want to find out. And so Dr. Anurag, your question will be answered at the end of today's session. So you will be looking at a lot of tests. I have not spoken about any test. Okay, I have just spoken about the general concept behind it. For in a cross-sectional study, for example, when our primary objective is to find out the prevalence.
Hello.
Yes.
Ma'am, please kindly explain that graph one, that p value, just again, just for a little bit. I couldn't understand. The critical value you told at the two sides, there will be 2.5, 2.5.
No, don't worry. See, don't worry. Okay, just remember that we decide our significance level at the start of our experiment. The V is the scientific community. It is 95% is acceptable. Okay, if you go below 95%, the scientific results that you get are not going to be considered valid. It is not scientifically sound. You can go above 95%. Some studies take it as 99%. Okay, so alpha will be set at 0.01, which means you will allow only 1% random error. Okay, but so commonly we do at 95%, which allows for 5% occurrence by chance. Okay, that P is probability. The reason we say less than 0.05 is because our alpha is 0.05. That means you allow 5% to occur randomly. Okay, we cannot ensure a very idealistic situation, right? We can't say we want 100% results. We have to account for practical occurrences. So that 5% accounts for random occurrence. So when we set alpha at 0.05, our probability of our result occurring randomly should be less than 5%. That is all there is to it. It is because we have decided alpha as 5%, which means in very simple terms, it means that our result can happen by random chance up to 5% of the time. If it crosses 5%, then our study result is not significant. Okay, so we are crossing its occurrence by random chance. Okay, so when probability is 3%, that is 0.03 or 0.02, 2% or 0.01, which is 1%. So when the probability of our result occurring by random occurrence is less than 5%, we will say our result is significant. So as a PJ, I remember I also have asked this question multiple times. How research methodology works is you're being introduced to the concepts. It's very rare that you understand it immediately when somebody tells you. But when you go back and you do your homework and you add it with what you have listened to in these kind of sessions, okay, and when you work on it, okay, till you work on it, you will never actually grasp it. So you will definitely pick it up. So in a very simplified format, you remember that alpha is set by the researcher at 0.005, sorry, at 0.05 most commonly. Okay, and because we are setting alpha at 0.05, our significance level, P, our probability of our result occurring by random chance should be less than 0.05. That's all it means. I can see a lot of questions here. I don't know if I have time to answer it. So there was one question that I was trying to read. Dr. Mohammed Kashif, if you're online, can you just tell me what is your question? I'm not able to see clearly here. For example, yes, Dr. Mohammed, are you? Yeah.
Can I, ma'am?
Yes. What is your question?
So my question was, so should we state the null hypothesis and alternate hypothesis explicitly for all the studies before we begin? For example, if we,
yes, tell me.
For example, if we take a cross-section study where we just want to find out the prevalence, the concept of the null and alternate hypothesis, we are not testing anything there. We're not finding the association there. So that wouldn't be valid, applicable there.
Can you give me an example of a cross-sectional study that you're doing? Or
so, for example, in the same example that you gave regarding maternal smoking and its effect on gestational age and birth weight. So, for example, if we are trying to find out just the prevalence of maternal smoking in pregnancy and not going to find out any other association. So what do we state our null and alternate hypothesis?
No, so now if you just want to find, so this is actually, so it won't be my thing. What you're doing is you're going at level 1, you just want to find out the prevalence of smoking among antenatal mothers, right?
Yes, ma'am.
So this is coming from review of literature, right? So you're interested in this because you think that there is a reason to it, no? So you don't just randomly want to find things. You want to find because you think it has an impact on children, isn't it?
Yes.
Yeah, so when you do your review of literature, when you refine your research question, it starts with a doubt. Okay, then you review literature and then you formulate your research question. Based on the research question, you will generate your alternate and null hypothesis and alternate hypothesis. So actually what happens is, your question is more a question of, is it research actually? So the simplest rule of thumb is, okay, if you want a number and if that number can be answered by a Google search, it is not research. So what proportion of patients are actually smoking? Okay, or what proportion of antenatal mothers are smoking? It is a statistic that might already be available, right? So your research question needs to go a little deeper.
Okay.
Yes, ma'am. Can I add on, ma'am?
Yes.
So actually, to answer your question, sir, so if we are just going to identify only the prevalence, so it is basically a descriptive study. So in descriptive study, we don't have the concept of null hypothesis or alternate hypothesis because we are not going to test the hypothesis in the descriptive study. So there is no point in having a null hypothesis or an alternate hypothesis or testing the hypothesis in case of descriptive studies where we just check the prevalence. Okay.
So
That's
I'll just
it.
add a point. So I had a slide on hypothesis generation and testing, right? So this is an example of where you would generate a hypothesis. So for testing a hypothesis is where we will have a null and an alternate hypothesis.
Yes. Yes.
Ma'am,
Yes.
ma'am, we are telling that if the p-value is less than 0.05, it is significant. It is only in case if we take confidence interval as 95 or
Yes, yes. Only when your confidence interval is at 95%. Yes.
if we are taking 99%, p-value we will set like less than 0.01.
Yes.
Okay, thank you, ma'am.
Okay. So shall we move ahead then? So I have shared my
Yes.
email ID. And
Sure. So the
Dr.
participants, if you have any more doubts, you can just put it in the WhatsApp group. It will be answered.
Yes.
And majority of the doubts which you might have at that moment will be covered in the further sessions. Okay, so please wait for the further sessions also to be completed. This is just a brief introduction that ma'am has given us regarding research. What are the various types of data that we will be using? And what is the distribution and how to test the hypothesis, what is this type 1 error, type 2 error. Just a brief intro about each concept ma'am has given it. And in the further sessions, you will get to know about the things much more clearer, and some elaborate things will be covered in further sessions. So thank you, ma'am. Thank you for your elaborate and excellent presentation, ma'am. And next, we will be moving on to the data importing and also some SPSS interfaces, everything will be covered. And before moving on to the next session, I request all the participants to kindly download the data set which is being shared in the WhatsApp group. I will just wait for 5 minutes. Then we will go to the next session where you will be seeing how to import this data, that is the Excel sheet, into the SPSS and how the data entries can be done, data cleaning, and all these concepts will be dealt in the next session. So before going into the next session, please all of you download your data sets that has been provided in the WhatsApp group. And also please install the SPSS also. It has been already instructed many times to just download the SPSS and keep beforehand, so that we can side by side you can also do when we instruct to do some things. Okay, so that will be a very good hands-on for you, because understanding all these concepts in a single day is very difficult. And only if you practice, you will get many doubts. Okay, so here we will be telling all these concepts where you might not have a much of a doubt, because you will mostly going with the examples which we quote. Whereas in the scenarios or in the researches which you are doing, you might get many doubts. So please, side by side, you also do the hands-on in SPSS. So thank you. So please download the data sets at the earliest. We'll wait for 5 minutes. By 10:20, we will start the next session.
So all the 8 data sets, sir.
Yeah, 8 data sets. So it will be for the overall hands-on. Okay, for all the sessions, overall, I have just shared the data set.
It is showing can't download file.
Ma'am, kindly download the SPSS software, ma'am, because these data sets will run in the software only. So please download it. So that
Not able to download the data set.
Kindly check your connectivity, ma'am, because it is a shareable thing only which we have shared. which can be easily downloaded. Kindly check once again and check with your connectivity, ma'am. Okay, I hope everyone would have just downloaded the data set. As instructed, the data set will open only in SPSS because these are SAV files, and you just install your SPSS and you just log in. Then you just open the data sets that will open. Okay, so next I would like to invite the next speaker, Dr. Anant Ishwar, and he has done his MBBS from Meenakshi Medical College, Kanchipuram, and has done his post-graduation in MD Community Medicine from the Sri Balaji Medical College and Hospital, and is currently working as the assistant professor, working as the associate professor in the Sri Balaji Medical College and Hospital, and he has a vast experience in the field of research, and he has done various collaborative projects, and is currently doing an ICMR collaborated project with a funding of around 33 lakhs. And he has done nearly 54 publications in various national and international journals, and is one of the resource faculty for training programs on SPSS and various other software management at the state and the national level. So with this short intro, I would like to invite Dr. Ananteshwar sir to kindly take over.
Thank you, Dr. Vivek speaking. Am I audible?
Yes, sir, you're audible.
So I welcome you all to the workshop. So the first session would have given you a research methodology, study design, and the hypothesis testing and all that. So with that, we'd like to first give you an introduction about SPSS. So many people have told that SPSS is not opening or not able to sign in. See, this is a very resource heavy software. So a lot of factors may play a role in not opening. The first thing is make sure that you don't have a expired version of SPSS installed. For example, if you have installed SPSS some 2 or 3 months ago and it has expired, so even hello, is my audio clear now?
Sir, it is breaking in between.
Breaking in between.
It is not clear.
Yeah. Okay. 1 second.
Yeah, yes.
Am I audible now?
Yes, sir, you're audible.
Okay. Okay, so as I said before, if you have used a version of SPSS before and it has expired, you won't be able to install the software. Even if you change the email ID and put, there will be issues with activation, and sometimes some people may even get a message that it has already expired because SPSS tracks your IP address. It won't have your email IDs. Then like we can have some 10 email IDs and have unlimited file, right? So it will track your IP address, because of which once you have used in your system and it has expired, it will be difficult for you to install again. Okay, so if you are unable to use the SPSS, don't worry, you just have a look. Work out your technical issues in your system. You will have the recorded lectures with you, so you can access the data sheets and work on it anytime you want. Okay, so as such, as of now, I will just cover over the basics, which you can watch over now. I will share my screen actually. Okay. Is my screen visible?
Yes, sir, it's visible.
Okay. So this is the data set which we'll be handling today. So each data set will be having each and every exercise. So for example, this is for the compute variable, this is for missing values, multiple option, and this is the Excel data sheet, this is the coded data sheet, and this has some out of range values. So each and every concept which I'm going to teach now, it can be handled by each data sheets, which I will go through one by one. So initially, most of you people would be doing the what is that? Data analysis in your Excel. So as a part of your thesis, and also some people may be using the Google Forms. So as and when you enter the data in the Excel sheet, it will be looking like this. Okay, so here will be the variable names, age, occupation, education status, marital status, religion, number of families. So this will be the classical data sheet which all of you will be having. So first, I will go over the basics of the user interface of SPSS. Okay, so if you see over here, this is the Excel opening sheet. As soon as you open, you get something like this. Okay, so this is the plain data sheet. And here, if you see here, you have something called the data view, and you have something called the variable view. Okay, so first I will go through the each and every icons and toolbars and everything you have over here. So you have the file option here. So in the file option, you have the new, you have the open. Kindly mute your mic. Okay. So you have the file option here. You have the new. So here, if you click new data, you will be able to open a new data. And here, if you have open already saved data, so you can open your SPSS, and if you open the data over here, the SPSS data set, all the .sav files will be shown here. .sav is the format in which SPSS files will be saved. Keep in mind .sav. Okay, like for example, for PowerPoint you have PPT, right? .ppt, like that you have .sav. So they can be opened only by SPSS. Okay, so this will help you to open the data which you already have in the SPSS form. And here you have the input data. So input data, you have Excel and CSV, the common things which we use. Okay, if you go to the Excel and click, it will ask you to search for the data sheet in your system. So whatever data sheet you have, you can click that and click open. Okay, so as of now, I am clicking the nicotine data sheet, which I have shared with you all. So I click on the nicotine data sheet, I click on open. Okay, so if you see here, over here, it is showing read variable name from the first row of data. Okay, so from the first row, it will calculate the variable name. Okay, next percentage of values, ignore hidden rows and columns. Okay, all these things are default, so don't touch anything over here and click on OK. Okay, so the data sheet has come. The data sheet has come. So I have totally 105 data. So the data sheet has opened. So some issues some people may face, which I am just telling you. If you download anything from the internet, okay, if you download anything from the internet, for example, I'm showing you, this is the Google Drive link which has been shared by Dr. Vijay Karthikeyan. So if I click on this data sheet and right click and download. So it has downloaded. Okay. So this nicotine data sheet I am opening. Okay. So if you see here, there's something called enable editing. Okay, enable editing. So since it is downloaded from the internet, Excel is warning you that it may not be safe. It may not be safe. Okay. So if you have to give enable editing and click on save and close this. If you don't do this step, and you import the data sheet over here, it will say that the cells are empty. Most of the students face this issue. We will send them a data sheet. They will download the data sheet and import the data sheet. They will go import and they will go to the Excel and click on it and click open, but it will say that the cells are empty. That is because they have not done this step. They should give enable editing. They should open in the Excel sheet first. They should give enable editing. They should just save it once and then they have to close this. Okay, and then they have to close this and then they can go to the SPSS and they can open the data sheet. It will open the Excel sheet over here. Okay, it will open the Excel sheet over here. Okay, so now without going into this one, I will open an empty data sheet so that I will be able to like teach you from the beginning. So next you can ask me, sir, what if I don't want to like, which is the ideal software to do data entry? That all depends on the preference. For my dissertation, I did my data entry in SPSS because I had the physical Excel sheet, physical questionnaires with me. So I entered the data in SPSS itself. So that all depends on your preference. If you want, you can do it in Excel. If you are good in handling SPSS, you can do it in SPSS also. Okay. So what you have to do is, this is the data view. This is the variable view. You cannot create it. You cannot create or type anything over here. Okay, because none of the variables have been defined. So this is the variables. In the data view, the top thing is the variables. Okay. So for example, I'm going to the variable view and you have something called name, type, with decimals, label, values, missing, and columns. Okay. So each and everything I will go through one by one. So first is the name. For example, let us say I'm going to give something called name of the participant. Okay. Now watch closely. Now I'm going to click enter. Variable name contains an illegal character. So keep in mind that in SPSS, in the name column, the name of the variable, okay, in the name of the variable, you are not allowed to have any kind of space, okay. So here you have to go like this, name underscore, okay. Beside the 0, you have the underscore. You have to press shift and press the underscore button and give name of participant. Okay, so name of the participant. Now it will show the type. So in type, you have the numeric. I will just go through what is necessary for you. You have the numeric, you have the string. Just concentrate on these two things alone. Numeric is, as you all know, 1, 2, 3, 4, 5, 6, 7. Okay. And string is the characters, number of characters. Okay. For example, a person name, for example, I'm going to put my name as Ananta. So how many characters? A-N-A-N-T-H-A, 7 characters. So 8 is okay. I usually names will be a little long. Okay. For example, Dr. Vijay Karthikeyan, his name is a little big. So if I want to type in over here, it will stop with the 8 letters. It will stop with 8 letters. So what you have to do is, this you can set something arbitrary like 50 or something like that. And you can click OK. So here the type is string. only if the type is string in the data view, the variable which I created has been shown here, name of the participant. Only then I will be able to type my name over here. Only then I will be able to type my name over here. Okay, if I have this as, for example, if after typing, if I change the type of the variable to numeric, let us say numeric, the name will disappear, because in numeric you can enter only the numbers. In string you can enter the name, okay, and also the numbers, okay. But if you keep a numeric variable, you cannot write any kind of name over there. See, I am now typing something and clicking enter, it is going out, because the variable is classified as a numeric type. Okay, so depending on your variable, you have to give your type as either string or numeric. Okay, next in the label you can have space. The label you can have space. For example, you can type it like name of the participant. Okay, name of the participant. You can have it over here. So I have declared one variable, which is name of the participant, which is of type string, which I can have up to 50 characters, and the label is name of the participant. Okay, so first variable. In all of our research surveys, the first variable is what? Name. Okay, so next is the age of the participant. Age underscore of underscore participant. Okay, it is numeric. Yes. Does it have decimals? Do we have like some 8.5, 7.5? No. For age, we are usually going to use whole numbers. So I'm going to go to this and press down over here, and I will say that SPSS, this variable will not have any decimal points. And in the label, I'm going to give us age of the participant. Okay, so here again, now I can go over the data view. I can see the age of the participant over here. And if you see over here, here is something called measure. Okay, here is something called measure. So here you have the nominal, you have the ordinal. I think it would have been discussed with you already. Nominal data carries the name, the gender, okay, male, female, upper class, lower class, sorry, not upper class, lower class, some classifications, okay, some categories will come in the nominal data. Ordinal data, some ranking may come, mild, moderate, severe, okay, and the marks they scored, some ranking will come. So you can see the symbol itself over here. Some ranking may come, and some it will be like ordinal in nature. Here it will be categorical in nature. So in string, you can show whether it is nominal or ordinal. This component you will usually use while using the statistical test. Okay, so as of now, you can just have it as nominal. A variable which is going to have purely numbers, it is going to deal with pure numbers. You can give it as a scale measurement. Okay, it is going to measure, okay, the age of the participant, 45, 55, 65. So it is a scale, it is measured in scale. Okay, so this is regarding the age of the participant. So here the age of the participant, I can give like, for example, age of the participant. So, sure, age of the participant. So I can simply go about typing names. Okay, so each person, for example, the person Anand has a age 44. So Ishwar has a age 36, Bala has a age 35. So we have only two variables over here, and we have three data over here. So likewise, you can create how much ever variables you have in your question. Okay, for example, you can create something called education. You can something called occupation. Okay, you can create something called socio-economic class. Okay, now we will define each and everything. So we have education over here. So again, I am going to give education. just to speed things up, I'm just labeling it like this and socioeconomic class. Okay, so again, always keep in mind, this is we are going to like go about, because here if you see, the education is over here. For example, let us take, you are giving like each and everything in SPSS once on coding. Okay, so I will deal with it more in detail in the next data sheet. So first, let us take education. We will have just two categories. Okay, we just literate and illiterate. Okay, literate and illiterate. But I am going to denote one as the literate. Okay, two as the illiterate and one as the literate. Okay, so as soon as, see, this is another shortcut. Education is over here. I am going and clicking on, double clicking on 3. Okay, it will go to the variable over here. And if I double click over here, it will go to here. So switching from data view and variable view will be seamless if you click on this and this. Okay, if you have some 40-45 variables, it will be always difficult to search each and every time, where's the variable over here, where's the variable over here. So always go to the variable view, find the variable you are interested in, go to the left side of it, in the serial number, double click, it will take you directly to the variable. Okay, so education, does it need decimal number? No. So I'm going to remove. Occupation, decimal number? No. No. I will just remove that. So in education, I have given 1 for literate and 2 for illiterate. Okay. So here you deal with something called values. Okay. In values, I'm going to give 1 as literate. Enter. 2 as illiterate. Enter. Okay. And again, I'm going to go into occupation. I'm going to type 1 as employed, 2 as unemployed, and 1 as employed. Okay, so here I'm going to double click over here, switch to occupation, click on values, and give the value over here. I'm going to give 1 as employed and 2 as unemployed. Okay, and I'm double clicking for and going back over here and socioeconomic class. Okay, and socioeconomic class, I am going as 1 as the upper class, 2 as the lower class, and 1 as the upper class. Okay, I'm going to double click SC class. I'm going to double click SC class and I'm going to define the values. Okay, so define the values, 1 as upper class, 2 as lower class. Okay, so just a simple way to define the variables I'm just showing you. So I have given over here. So we have 5 variables over here: name of the participant, age of the participant, education, occupation, and socioeconomic class. Okay, so here I will move to the other icons in the toolbar. Okay, we have something over here. Okay, we have something over here. Watch over my mouse cursor. We have something over here. If I click on that, there is something called value labels. There is something called value labels. So I'm just clicking on that. It is now showing how many literate and how many illiterate are. Okay, and now tell me, now this education, what measure it is going to come? Okay, it is going to come in scale or ordinal or nominal. You can unmute your mic and answer.
Ordinal.
Nominal.
Ordinal.
Okay. The reason ordinal you can use, but ordinal is used for ranking. Okay. For example, if education has something like primary school, middle school, high school, graduate, postgraduate, you can use ordinal because it is a way of ranking or classifying. Here you have only two categories. You have literate and illiterate. So nominal will come over. Okay, same for employed. Okay, it will have nominal. But in upper class and lower class, it is some kind of ranking, right? Based on some category, based on some how much amount of money they collect or the monthly income, you're classifying them as upper class and lower class. So here it can come as ordinal, but this ordinal and nominal will not come into play until you are dealing with specific analysis, which we
Excuse me,
will be
sir.
dealing in.
Excuse me, sir.
Uh,
Sir, can you
yeah,
show
tell me.
once again what changes you did in variable view in label part so that it is showing 1, 2, and it is showing in the data view? Can you tell it again? I couldn't understand
Yeah,
that.
sure.
That
Yeah, sure.
that it showed. Yes, it showed. What changes you did in variable view? Label it. How did you label it? Like 1, 2 in that next you show time you show that one.
Yeah. Okay. So if you go over here, you have the education over here, you have the occupation, you have the socioeconomic class. Okay.
Yeah.
So in education, I have kept one as the literate, two as the illiterate. Imagine I am having some kind of questionnaire with me. So if I am going through the data of Anand, if Anand has literacy, okay, if Anand has studied, I would have ticked the literate column. So that literate will be A and literate will be B according to the questionnaire. So A I am denoting as 1 and B I am denoting as 2. Okay, so this Anand data is literate. This Anand is literate. So A, I would have ticked A. So that literate I am keeping it as 1. So Ishwar data, he is illiterate. So I am keeping it as 2. And Bala is literate, I am keeping it as 1. So as soon as I enter the data here, I have to tell SPSS what is 1, what is 2, and what is 1. Okay, so I am double clicking the education. I am double clicking over here, not over something, not somewhere over here. Okay, I am double clicking the education and going to the values. And inside the values, I am defining 1 is literate and 2 is literate. Okay, and I am going back to education, and here we have the icon which is going to show you the value labels. So I'm clicking on value labels and checking whether the value has been properly assigned to 1, 2, and 1. Okay, I am clicking over here. It is showing correctly 1 is literate, fine. 2 is illiterate, fine. 3 is literate, fine. Okay, so ideally what you need to do is, since I am just showing you people, I am going this way, but ideally what you should do is, you have to fill all the variables first. For example, if you have some 20 questions with you, all the questions will come over here. Socioeconomic class. Here we have the data sheet regarding the nicotine dependence, right? So all the questions will come over here, and all types you have to define over here, and all the values you have to assign. A, B, C, D options you will have, right? So A is 1, B is 2. You have to assign. Then you have to go and enter the values over here. Okay. Is it clear, ma'am?
Yes, sir. It is clear. Thanks.
Yeah. Okay. And someone was asking a doubt.
Sir, how come education be a nominal data?
See, that's what I'm saying. Education depends on the classification you give to them. As of now, you can either have it as ordinal or nominal. As I said before, ordinal and nominal both are qualitative data. Okay. So whatever you give over here doesn't play a role unless and until you take it for analysis specific to that particular. For example, ordinal data will be handled in Spearman's correlation. Okay, in Spearman's correlation, ordinal data will be handled. So specific statistical test only will come into play. The only thing which you have to keep in mind is the measure. Okay, the measure. For example, age, hemoglobin level, height, weight, all will be measured on a scale. Okay, and all the other categories will be measured on either ordinal or nominal. Mostly nominal. Okay, mostly nominal, but you have to be careful and assign whether it is nominal or ordinal only when you go for the specific analysis, which we'll be dealing with in the upcoming sessions. Okay, upcoming sessions. Usually ordinal data will have an order. As you pointed out, education can also be a ordinal data. It all depends on what classification I have over here. Okay. For example, in modified Kupasamy scale for education, you have some 7 categories. That will be ordinal data. Okay. If I have only 2 categories, employed, unemployed, educated or not educated, then it will become a categorical data.
Sir, if we
Okay.
take a BG Prasad scale for classification of education, then it will be an ordinal scale, na?
Yeah, exactly. If you use any scale, for example, socioeconomic status scale, for example, depression scale, you have some mild, moderate, moderately severe, and severe depression, it will come under ordinal scale. Okay, so that's what I'm saying. In SPSS, that doesn't play a major role unless you are dealing with specific analysis. What plays a major role is, are you defining the scale variables correctly? For example, age of the participant should have a scale division over here. Because when you go for advanced analysis like regression, it will not take the nominal data inside. It will not take the nominal data inside. So those times you have to make sure that it is a scale variable. Okay. So this is the basic data entry and coding. So here, this section carries the variable name. Here you declare the variable. Whether it is numeric or string. Here you say how much is going to be the width of the variable. Okay. And here you say the decimal points. For example, hemoglobin and all can have some decimal points, right? You have some 11.5, 12.5 and all those things. And here you can, this is the label. See, name, SPSS will not accept spaces in the name. Okay, so if you want to define the like name in a way you can easily understand or which spaces you want, you can put the full name in the label over here. Okay, and if you have coded the categories, you have to define the values. Okay, if you have put based on the options you have A, B, C, D. If you have put it as 1, 2, 3, 4, what is 1, what is 2, what is 3, what is 4, which will correspond to the A, B, C, and D in your questionnaire. Okay, and next you have to define whether it is a scale or a nominal data. Okay, clear? Any doubts you have in this?
No, sir.
Okay, so now we will be, yes. Someone was asking something?
This missing columns, all these are corresponding to what?
Which one?
This missing.
Yeah. That I will show you. Missing data and all these things will come later. I will show you in the subsequent data sets. Okay. So data entry is done. Okay. Now, so what I'm going to do is, I'm going to go into the
Sir, one more doubt. Can you please tell the difference, exactly the difference between what is the name and this label?
okay. So this name over here is the name of the variable. Okay, name of the variable. So whatever language you use, for example, persons who are in like a little bit of computer languages, it won't accept any kind of spaces. Okay, the variable name will not accept any kind of space. Okay, so this is for the SPSS. The label is for you to understand. Okay, for example, the question may be like, let us take obesity. Okay, how many like per week, how many times do you consume junk food? Okay, so per week, how many times you consume junk food? So that time, no, you cannot put the whole thing over here. You cannot put the whole thing over here. So in the name, you can just put junk underscore food underscore frequency. Okay, and in the label, this is for you to understand what question you are dealing with. Okay, what question you are dealing with. So here you have to put in the wheat. How many times do you consume junk food? Okay, this is just the name and the label. So label can accept space. It is for you to understand. For example, all the questions you have in the questionnaire, you can have in the label. And the short form of those questions without any spaces, with underscore, you can have it in the name.
Okay,
Okay.
sir, understood.
Sir, I have a
Sir-
doubt that hello.
Yeah, tell me, sir, tell me.
Yeah, sir. You have explained beautifully that with decimals, but sir, what does these columns depict?
The columns will come into play, sir. For example, see, can you see over here? The name, the name column I have kept 1. See how short it has become. Now I am increasing the space. Okay, the columns have become 13. Okay, now I am again increasing the space. Okay, the columns have become 56. See, if you have a very big data set, it is going to have each and every variable arranged over here, right? So if you have some 40-inch monitor with you, you can have as much in your vision, in your field of vision. I am saying here field of vision. Okay, wow. But if you are using a 12-inch laptop or something, then you want to like reduce the space, right? So you cannot like go to all the 50 variables and do. Do you see that? All the 50 variables, if you go and click and move it, so that you want to see at least 20 variables in your vision. So that time what you can do is you can go over here and you can go and adjust. Okay, 10 columns you want here. Okay, so here I want 10 columns. So here I want 10 columns. So here I want 10 columns. So it will uniformly distribute the size of the it will uniformly distribute the width of the columns. Understood?
Yes, sir.
Okay. How to enter values and labeling? Just now I told. So anything else? Is it compulsory to code the data into values? Yes. Yes. Because I will say you why. See, some people know they may like keep it as the education, they may keep it as literate and illiterate. Okay. They may just hypothetically, I am telling, I am just going to education alone. I am going to, okay, let me make a new variable over here. Leave. Okay, so I want to enter. So I'm keeping it as string. So only string will, so sleep adequacy. Okay, so now as one of the person pointed out, I am going to write sleep as it is. Okay, the two categories I have is adequate and not adequate. Okay, adequate and not adequate. Follow me carefully. Adequate and not adequate. And I don't want to code. I am going to enter as such. Okay, so what I'm going to do is I'm going to give adequate. Okay, adequate. Okay, if you see over here, I have written adequate over here, and I have written spelling mistake over here. And again, I can make spelling mistake over here. So this will cause a lot of typos. And typos will not be handled correctly by SPSS. And second, whatever analysis you are planning to do, only if you code, you will be able to do the analysis. Okay, in Excel, you are going to type everything. Okay, you are going to type everything like graduate and above, graduate and above, graduate and above. It will lead to lot of typos. Okay, so that is why I advise. Okay, that is why I advise. I suggest you can do data entry in SPSS itself. Okay, having declared the variables as questions over here, and having declared the values as code over here, and just you are going to give 1, 2, 1, 2, 1, 2. You are going to enter just that. You are not going to type anything. You are not going to type anything. You are just going to input for each and every variable the value over here. Here 1, 2, 1, 2, 1, 2. This is alone you are going to enter. After you enter, if you click the value labels, it is just going to show you easily. It is just going to show you easily. So the reason why you have to code is, 1, it is for the analysis. 2, it is to avoid any kind of typos which may come. Okay, any kind of typos which may come. So that is why you have to always code the variables rather than keeping it as typing it as each and every time. Okay, clear? Any other doubts?
Sir?
Yes.
Sir, if we had a large questionnaire for example, more than 50 or so questions, so it is advisable
Okay.
to use Excel, or should we enter each and every question in SPSS?
So that is what I'm
What is
saying.
better?
Yeah, the Excel, as I said, it is a very easy, straightforward software. It is a very easy, straightforward software in which you can declare the variable names above and you can declare the values over here.
Yes.
Okay, but the thing is, you have to make sure that you don't carry any kind of typos. Okay, and spacing over here. The thing is, backup will be easy in Excel. Okay, backup will be easy in Excel. Backup will be always easy in Excel, and SPSS sometimes may sometimes crash in between. So you have to make sure that you frequently save the file over here. What I could advise is, if you are using Google Forms, you will already be getting an Excel sheet. Okay. If you are manually entering the questionnaire, you can if you can, without any typos or without making any mistakes, if you can enter in your Excel sheet, well and good. No, I have a time constraint, I have to finish it soon or something like that. If you have, you can go into SPSS. You can first thing is you can declare the variables, then you can start writing that. You can start writing the codes directly. For example, in this question, I have around 30 questions over here. So it will be easier. It will be easier for me if I just code type 1, 2, 1, 2, 1, for example, 1 Hinduism, 2 Christianity, and rather than typing Hinduism, Christianity separately.
Yes.
Okay, so it's all personal preference. One second. Yeah, sorry. So clear. So it's all based on personal preference. But if you are using SPSS, you have to make sure that you back up frequently. I repeat again, you have to make sure that you back up frequently, because nowadays Excel have a autosave feature. So even if something shuts down, your laptop crashes, something shuts down, you can have something called auto recover, which will show you that while you were working on this Excel file, there was a random shutdown or a random crash which happened. Can I recover? The Excel will ask you. SPSS will never ask you. Pochna.
Yes, sir.
Okay. So regarding the data safety, I will suggest you to use Excel. Regarding the speed regarding the speed which you can enter a voluminous data which contains more than 50 variables, I would suggest you to use SPSS, but make sure you save frequently. Okay. Okay then. So we are running out of time, I think. Maybe you can just put down your questions in WhatsApp on the chat box. Next, we will go to like data cleaning. Okay. So data cleaning. So data cleaning will help you to identify the missing data. Okay. So for this, I will open the Yes, is the data sheet visible now?
Yes, yes, it's visible, sir.
Yeah. Yeah. So this is a data sheet. Okay. This is a data sheet regarding diabetes. So you have the age of the person over here. You have the gender over here, religion, alcohol consumption, smoking, diet, sleep, eye, and diabetes. Okay, eye and diabetes. So here, first I want to see if any data is missing. Okay, first I want to see over here, any data is missing or not. So while even I look, you can see some data is missing over here. But again, if you have a voluminous amount of data, you may not be like having a glance at your data sheet. Can you mute your mic? So just having a glance, you may not be able to find the missing data. It may be located down at the bottom or something like that. So how you have to find the missing data is, you have to go to analyze. You have to go to descriptive statistics. Okay, so first I will just show you. So I showed you the file toolbar over here. So here you have the data, you have the transform, you have the analyze, you have the graphs. This is what you're going to use usually. So in analyze, the first thing you have the descriptive statistics. Okay, in descriptive statistics, you have something called frequencies. Okay, so I'm going to click on frequencies. Okay, and I am going to select all the data. So so again, I'm going to teach you a shortcut. So age of the participant, I'm just having my mouse over there and pressing Control plus A. Follow with me, Control plus A. This is Control plus A is a universal key. Either Microsoft Word or Microsoft Excel or SPSS. It is the universal key to select all the variables or all the data in that. So I'm just going to click Control and A, and I am going to move it over here. I am going to move it over here. Okay, move it over here. Then I am going to click OK. Okay, so now coming over here, this is something called the output window. So SPSS uses two windows. Okay, two windows. One is the data sheet you are using, and the other is the output window. Okay, in the output window only, you have divisions like this. Okay, so here, what you see on the left side, here is each and every variable you have here. Okay, now I have given frequency table, right? So each and everything will come over here, data sets and all those things will happen over here. And this is the code. This is the code. Okay, this is the code. So this is something called backend. This is something called front end. Okay, so this is what you will be dealing with. What you are giving, what input you are giving, and that is going to be shown in this window. This window, we should not be bothered and we should not disturb. This importance of this window, I will come over in the later sessions. Okay, so in this statistics, if you see, all the variables are over here. Here you have something called valid. Here you have something called missing. Okay, here you have something called valid. Here you have something called missing. Okay, for example, age of the participant, we have 161 data, among which 4 data are missing. Gender of the participant, we have 161 data, among which 4 data are missing. So this is how you identify the missing data. Now what I am going to do is, I am going to minimize the output window. And I am going to the age variable. As I said before, I click on AGE, I click on that. Okay, so I want to find the 4 missing data. In front of my eyes, I can see 1 missing data. Okay, so I want to see the other missing data. So what I'm going to do is I'm going to right click. Follow with me. I'm going to right click and you have an option called sort ascending and sort descending. Okay, I'm going to give sort ascending. So here it has come. See, the 4 missing data has come over here. So again, you may have some voluminous amount of data. Okay, for example, some 500 data or something. So in that, some 10 data may be missing for you. 10 data may be missing for you. So you just want to input those data, but you cannot input simply, right? For example, you have some glycemic values. You have some glycemic values, and as the as the age goes higher and higher, the glycemic values may become higher and higher due to some uncontrolled diabetes or whatever. Okay, so you simply cannot guess and put something over the age over here. So for that, you have to go to transform. Okay, earlier we went to analyze descriptive frequencies. Okay, now I want to replace the missing values. So for that, I'm going to transform. I'm going to go to replace missing values and I'm going to put age. Age in age only we have like 4 missing values. So I'm going to take the age inside and I'm going to say that it is going to create a new variable, age underscore 1. Okay, so the method is series mean. Series mean. So based on the calculation which the SPSS has inbuilt, based on the values of the other numbers and based on the values of the other variables, it itself will assign some value to the 1, 2, 3, and 4. Okay, so I'm going to click OK. So now a new variable has come. Now a new variable has come in which it has come 72, 72, 72, 72. So this SPSS itself has calculated that based on the values of the other numbers, based on the data of the other numbers, based on the mean value, it has created and given us, okay, these may be the missing values like this. Okay, so we ourselves putting some values is different from SPSS identifying and replacing the values. So always, Vanda, you have to keep in mind that, you have to deal with missing values with the SPSS built-in option of replace missing values. Okay, and even in gender, you have some missing values. These and all are categorical variable. These are all categorical variable. Okay, so in this, you yourself can input because this have like only one category, right? Like that. No, so this you don't need a help of SPSS to calculate the series mean and tell whether it may be a male or female. Nothing like that. So ideally, what you should do is you have to be careful in data entry. You have to make sure that you don't make any mistakes. And if at all mistakes happen, you have to use the SPSS method of replacing missing values for quantitative data. Quantitative data means the numbers, because numbers only will create problems in the missing values. If you put something like without having any idea about the distribution, if you put something like 10 or 15, it may go in as outliers or extreme values. Okay, so without having any idea, don't comment or don't commit anything. You use the SPSS option of replace missing values for quantitative data. If you have a qualitative data like gender, religion, or something, you do a sort ascending, find out the missing values and assign the categories whether it is male or females. So this is the replacing missing values. And second is the outliers. And extreme values. For example, let us take over here. This age category. So this has some, first I'm going to check the extreme values. Okay. So for that, what I will do is, I will again go to analyze. Extreme values, we understand. If the age of the participants is between 18 and 45. Suddenly, if someone age is 135, follow me correctly. Someone's age is 135, it is not practically possible. Okay, maybe 35 may have been miswritten as 135. Okay, so that is known as extreme values, which are caused due to the error of the investigator. Whoever is doing the data entry, some manual errors may happen. After all, we are all human beings, right? So some manual errors may happen, because of which the values may misinterpreted as, for example, 72 may be like 72 may be, okay, first I will remove the decimal from here. Okay. 72 may be miswritten like 712. Okay, if you see here, when I am doing the data entry, I have mistakenly written 71 as 712. So this is the extreme value, and this has to be identified. So how we identified to analyze? You have to go to this, you have to go to frequencies. Okay. So this age in statistics, I'm taking the age alone inside, and I'm going to the statistics, and I'm giving something called minimum and maximum. I'm giving minimum and maximum and giving okay. So here if you see, the minimum is 40. So this study is done among the elderly. So elderly and middle-aged people. So it begins only in 40. But see the maximum 712. So this is the extreme value. So what I will do is, I will go to my data sheet and right click over here and give, I will right click over here and give sort descending. If I give sort descending, I will be directly taken to the value which is very extreme. Okay, then I will edit and put 71. Clear? I will edit and put 71. For example, the extreme value may even be like this. For example, instead of 40, 4 may be extreme value. Okay, in 4-year-old child, you are not going to go and see diabetes or these complications. So what I'm going to do is, I am going to give sort ascending. I'm going to find the extreme value, and I'm going to put 40 over here. Okay, so this is the second part of data cleaning. As soon as you have an Excel sheet, as soon as you take it inside the SPSS, the first thing you have to do is identify the missing values. Second is, for each and every variable, identify the extreme values, especially in case of quantitative data. Especially in case of quantitative data, identify the extreme values. Okay, for example, now it is showing the value labels. I'm going to hide the value labels. Okay, so what I will do is, ideal way, instead of going for analyze frequencies and all that, each variable I'm going to click the sort ascending, and I'm going to see the sort descending. Sort ascending, sort descending. These are all categorical variables, so chances of errors are minimal. Okay, so this quantitative variable, I'm going to sort ascending, and I'm going to see sort descending. Okay, still if you are not sure, you can go to analyze frequency and see the minimum and maximum value and see whether they lie between your, steady hypothesis or steady population or whatever, the variable name. Okay, so third and final component of data cleaning is identifying the outliers. So for that, I will open the nicotine data sheet. Okay, nicotine data sheet. So in nicotine data sheet, I am just, so nicotine dependence is analyzed using something called Fagerstrom nicotine dependence scale. Okay, so this scale with which I am going to show you all the analysis. So I will just open the scale for you and show you. This is the Fagerstrom test for nicotine dependence. So these are all the questions. How soon after waking up do you smoke? Find it difficult. So these are the questions, and these are the scores for each and everything. And if you add all the scores, it will have something like low dependence, moderate dependence, low to moderate, and high dependence. So you have 4 categories over here. Okay, so that is what is there in this Excel sheet. Sorry, in this SPSS sheet. So you have the Fagerstrom score over here: 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, you have the Fagerstrom score over here. Now I want to check whether the Fagerstrom score has any extreme values. So what I will do, I will see the sort ascending and sort descending. Okay, it is within the limit. 0 to 10 is the limit based on the PDF I showed you. So it is within the limit. Okay, now I want to check whether the scale has any outliers or not. Whether the scale has any outliers or not. So for that, what I'm going to do is, I'm going to go to Analyze, Descriptive, and I'm going to go to the Descriptive section. Okay, Descriptive section. And I'm going to go and select the Fagerström score. Okay, follow me carefully, Fagerström score. In this, I'm going to click on Save Standardized Values as Variables. Save Standardized Values as Variables and click OK. So now a new variable would have come over here. A new variable would have come over here. So in this, I'm going to look whether anything lies between the value of Now I'm going to check whether anything lies between the plus or minus 3.29. Because in standard deviation, based on the normal distribution curve, which you would have came over in the last class. So in this normal distribution curve, plus or minus standard deviation, plus or minus 3 standard deviation. So whatever values, it has to lie between the plus or minus standard deviation. Okay, wow. So this plus or minus standard deviation will be checked with the standard residual values, which are calculated by the SPSS. So based on this, you have to check over here. You have to again sort ascending and check minus 3.29. Does it cross minus 3.29? Does it cross? No. It is starting, the minus value is starting from minus 1.858. Okay, now I'm going to do sort descending. Okay, does it cross plus 3.59? 3.29? No. So this data doesn't have any outliers. For example, let me run this again. For example, I'm putting something like 25. Okay, I am putting something like 45. Okay, now I am going and giving descriptives, and again I am saving the values over here. If I go over here, you can see that it is crossing the threshold of plus 3.29. It is 4.37, and this is 8.77. So with this, you can identify, okay, these two data which I have entered are outliers. Since Fagerström score is my dependent variable, with which I am going to do my whole analysis, I have to remove the outliers. So what I will do is, I will go to this 1 and 2, 1 and 2, and I will
So is
click
3.29
clear.
Always a constant?
Yes, constant. That's what in normal distribution curve, you have plus or minus standard deviation, right? 3 standard deviation, 2 standard deviation. It can go up to 3 standard deviation. Okay, so above that, the value should not deviate from the mean value. So you have to check with the Z score and check whether anything crosses plus 3.29 or minus 3.29. If so, you have to select those data and delete. Always remember, extreme values are because of typo, and it can be corrected. Outliers cannot be corrected. Outliers has to be removed. Okay, outliers has to be removed. This is called univariate outliers. Okay, univariate outlier, variate variable, uni one. So each and every variable, this is the method by which you can check the outlier. There's something called multivariate outlier, which is calculated by something called Mahanabi's distance, which I will teach you at the end of the class if time permits. It's a little advanced analysis. If time permits, I will go through that. But till now, you understand that the first step, after importing a data sheet, you have to do the data cleaning, identify missing data, identify the extreme values, identify the outliers.
Sir, excuse me, sir. So
Yeah,
just
tell
now
me,
you
ma'am.
told that outliers can be corrected. univariate
Yeah.
outliers, multivariate outliers, because which cannot be, they can be corrected and they can be cleared, but which cannot be corrected, that is for something we don't like to understand that.
No. I cannot understand your question. Your voice is little muffled up. Can you come again?
Hello?
Yeah.
Yes,
Tell
sir.
me, ma'am.
Now, am I audible?
Yeah, now you're audible.
Sir,
Tell
you
me.
just now told that outliers can be corrected, univariate or multivariate, they can be corrected by cleaning the data, clearing that or whatever. Okay, in outliers can be corrected. Now, then you told that something which cannot be corrected. What is that?
No. I
Z
told the
value or
extreme.
something.
I told the extreme values can be corrected because that is because of manual error, human error.
Can be corrected.
Extreme values. I told no, like 70 instead of 70, you have written 700. So that is a extreme value that can be corrected. You can change the data 700. You can change and put it as 70. But outliers, no. Outliers has to be removed. Okay, based on your data. Based on your data sets. Okay, because the problem with the outliers is outliers can disrupt the normality of the data. First point, it can disrupt the normality of the data without being warranted. For example, ideally, if you use a scale, for example, depression scale, the common depression scale, PHQ-9, you all would have heard about that. Okay, so common scale, depression scale, if you use, there may be a little less amount of people who has scored in the severe category. Okay, for example, some 18 or 20 or 21, there may be less number of people. Okay, so those times and all, if you check, they may show us outliers. Okay, they may show us outliers. In those cases, you can keep the outliers and use the non-parametric test. Non-parametric test means if outliers are present, the normality or normal distribution may be compromised. Those times you can go for non-parametric test. Okay, but sometimes the outliers may be there, and it won't be a issue if you remove the outliers. In case of depression score, severe depression has to be reported. Yes, you cannot simply delete the severe depression. Okay, it has to be reported. In those cases, you can retain the outliers and do the other alternative statistical test, which the outliers can handle. Okay, there are some statistical tests which are not affected by the outliers. Okay, listen carefully. There are some statistical tests which are not affected by the outliers, which will be dealt with Dr. Vijay Karthikeyan sir. So those tests you can perform and find the hypothesis, do the hypothesis testing. But if you scientifically think that removing these outliers will not affect my data set, you can remove the outliers. That depends on your personal choice based on the scientific literature. Okay, for example, you are doing a study among 18 to 65 years. 18 to 65 years. Okay, and all the patients which you have interviewed were between the age of some 25 to 45. Okay, only 2 participants were 65 years of age. Only 2 participants were 65 years of age. Okay, and only 2 participants were 18 years of age. So they will come as outliers because most of them lie between the age group of 25 to 45 years. Okay, so if only 2 participants are 65 years and if they show us outliers, you can remove those 2 participants because they are not going to disrupt your data. They are not going to disrupt the data, so you can remove those outliers. But in case of using a scale-based calculation like depression scoring, you should not remove the outliers. Those times you have to use the statistical tests which are not affected by the outliers. Okay, so it all depends on your judgment and your steady hypothesis. Okay, clear? Okay, then I think I am already very late. Okay, any other doubts you have on the user interface of SPSS, data cleaning, or anything else? Yes? Okay,
So if the
outliers.
part is
Can you please?
Yes,
you
tell
asked
me.
to enter the data manually in Spaces, but then can we re-download the data as Excel when once it is entered directly in Spaces?
Yeah, I think you can do. You can do go to Save As. You have something called CSV, no? CSV is the Excel sheet. Okay, CSV is the Excel sheet. So you have entered the data over here. Okay, now I want to save it as a CSV format. Okay, I'm going to give file name as like backup. Okay, and I'm saving it. Now if I go over here, I have the CSV file here. This is a Excel document. So I'm opening that. See, the Excel data has come. So I have backed up my SPSS as a Excel sheet. Okay, so SPSS data can be backed up as a Excel sheet, and the Excel sheet can be imported into SPSS. Vice versa, anything can be done. Okay. So I think if there's no more doubts, we can move to the next session, I think. Dr. Vijay Karthikeyan, anything else I need to cover?
No, sir. If there are no further queries, we can move on with the next session. The participants have any queries, kindly unmute and ask your queries. We have just a few minutes for discussion. Yes, ma'am.
So, excuse me,
Yeah,
sir.
yeah.
Now just was told that SPSS data can be converted into Excel, and Excel can be converted to SPSS. If it is entered in SPSS, can be converted into Excel. And that can be that the data that is entered in SPSS can be converted to CSV also.
Can be converted into what format you're asking?
CSV.
Yeah, that's what I showed you, right? You
Yes,
can go
yes.
to save. You can go to Save As, and you can save it as CSV.
Okay, yes.
Sir,
Thank you.
is there any easy way where we have taken the data via Google Form and all our data in Excel and to convert in that 0, 1, 2, 3 form for the SPSS? Is there some easy way to get converted in that particular format?
No, sir. Unfortunately, no. So when you download something from Google Form, it will come like this. Okay, it will come like this. It will come like this. So you have to convert that. And actually, there is a way which I can teach you. Like, Vijay Karthikeyan, can I utilize some 5 minutes?
Yeah, sir. You can utilize.
Okay. Okay, then. So now I will just, you are asking about some easy way, right? So I will just show you. So this is exactly something which was collected in the Google form. Is the screen visible? Is this data sheet visible?
Yes, sir. It's visible.
Yeah. So this is exactly something which is converted from a Google form. So what you can do is, see, you have the questions over here, and you have you consumed alcohol or any other substance abuse? It's the label. Here you have the Q1 without space. Without space you have here. This is how classically the imported Excel from a Google, you download Excel from a Google form and you import that Excel into the SPSS. It will classically look like this. It will classically look like this. So what I'm going to do is, see, you have professional over here. I will just remove this missing values. I'll just show you one variable on how to do that. Okay. So here you have the professional, you have the skilled worker, you have the unemployed, you have the unskilled worker. You have the unskilled worker. Okay. So what you can do is, you can just go over here. So what you're asking is, sir, I have to like, for example, if I have professional as one, do I have to like go to professional and give one? It is going to be a tedious process. That's what you're asking, right? So what we can do is, you can go to something called transform. You can go to something called transform, and you can give recode into same or different variable. Okay. In this, I'm going to select occupation. I'm going to select occupation, and I'm going to give occupation folder. As I said before, no space. Okay. And here you have occupation coded. Label can always have space. Okay. Label can always have space. So in this, I'm going to check the occupation. Okay, now you have to be very careful with the spelling. Okay, so here, professional. I'm going to code it as 1. Okay, so what are the other things? Professional, skilled worker, unskilled worker. Okay, so professional, I'm going to code it as 1. So skilled worker spelling, S is capital, W is small. So skilled worker, I'm going to code it as 2. Then unskilled worker, U is capital, W is small. So these things you have to be very careful. Okay. Unskilled worker. Label it as 2. Okay. So professional 1, unskilled worker 2, unskilled worker 3. And I'm going to click OK. Okay. So here I have the variable over here. This is the occupation coded. Occupation coded. So I'm going to double click over here, remove the decimal point because I don't need that. And then before I forget, I have to give the values. 1 is professional. 2 is unskilled worker. 3 is okay, I think I made a mistake. 2 is, I think, skilled worker. 3 is okay. So now we have the coded form of occupation. Okay, are we able to see over here? Rather than
Yes, sir.
Rather than going and giving like 1 1 1 1 1 2 2 2 2 2, you have recoded the thing into the. So here, if you give descriptive statistics, it is going to give you how many professional you have, how many skilled worker you have, how many unskilled worker you have. Okay, so like this, you can easily code each and every variable into the coding thing and can be done very easily. Okay.
Yeah, sir.
Okay, then I think we will conclude the basic of SPSS with this. Any doubts you have, like you can note and ask in the, subsequent sessions, hands-on sessions. Okay.
Not to me.
Okay, I think Vijay Karthikeyan sir, I think we can move into the next session.
Is my screen visible, sir?
Yes, it's visible.
Yes, thanks. So I hope all the participants from these 2 sessions would have got to know about what is an variable, what are the various types of data that we commonly use in practice, and how to just classify them. What is a numerical variable? What is a ordinal variable? What is a nominal variable? And what is the scale of measurement that we will be commonly using? And what are the various types of data? And also how to test the hypothesis. Okay, so brief note on everything would have been given in the first session, and in the last session you would have seen about the various interfaces in SPSS, how to code the data, how to identify the missing values, and all these things would have been covered in the second session. Okay, so moving forward, I will be dealing with mainly the descriptive statistics and yeah, I request all the participants to kindly unmute your mic and so that we can have a seamless session without any interruption. Okay, So in this session, I will be mainly covering on what are the tests that we commonly use to identify whether our data is normally distributed or not. And I will be highlighting on the descriptive measures also, the descriptive statistical measures, which we commonly use in practice. That will also be covered in this session. Okay, so before going into the topic proper, I just want you all to put in the chat box and identify these two characters. Okay, so the picture one, what is the name of the character? Picture two, what is the name of this cartoon? Okay, so the first picture is a famous character from a very famous, world famous series, I guess. Can you all just identify? Yes, right. Someone has put as Tyrion Lannister, right? So the Tyrion Lannister from the series Game of Thrones. Okay, so can someone identify the second picture? What is the name of the cartoon? Yeah, exactly. That is Dexter. Okay, so the cartoon is Dexter's Laboratory and the character name is Dexter. Okay, so it is one of the famous cartoon in the 90s where he would tend to do some funny things, and it will be projected. He tend to do various experiments in his laboratories, and
Sorry, you got muted.
yeah. Sorry. I was explaining about the second picture. Okay, so this is the Dexter Laboratory cartoon where the character Dexter in the day-to-day practice, he will be testing various things in his laboratory, and some new findings and all it will be coming, and it will be projected in a funny way. Okay, so moving forward, so moving forward, what are the specific learning objectives of my session? So at the end, the participants should be able to elaborate on various tests that we commonly use for normality testing. And also you should be able to interpret these tests. Okay, so here only our expertise is needed because we are not at all statisticians, and it is not our role to go and do all the calculations manually, because our life has become very easy due to the invention of various softwares. Okay, so and also many AI technology, AI tools has come into action, and they may help us in doing various things and make our job very easy. But our expertise, our role is to just interpret all these statistical tests and give the inference, because only if we are able to interpret the statistics and give the inference, we can write something in our articles about the test which we have applied, and based upon that, what is the finding or what is the conclusion you want to give from your research. Okay, because if you are not confident enough on choosing the ideal test or what to do with the statistical part, always you can just get the help of a statistician you want, and it is a good practice to do the statistics by yourself. But in a day-to-day practice, we could find that many might not be able to understand all the basic concepts in the statistics, because it is not been taught to us in an elaborate way from our schooling. It has not been taught in the even in the MBBS curriculum. We are not very much exposed to all these statistical concepts and all. In post graduation, to a certain extent, we just get to know about this. But when we go in depth, we have to spend time and do our homework, and we have to learn each and every concepts to go with the statistical analysis and all. But if you are not going to do any of this, if you want just the statistician to do the results, but you have to interpret it, because many the statisticians, they will just give you the output in the form of either in the figures or in the tables, but you only have to give the interpretation. Okay, so based upon the statistical values, based upon the p values, say for example in the case of correlation, based upon the r square values, what is the inference, you only have to give. Okay, so that you should be very much clear with. Second half of my session, I will be just dealing with what are the various ideal measures that you can use for describing your data. The descriptive statistical part also will be covered. Okay, so because depending upon the type of data, whether your data is a nominal data, ordinal data, or it is in the continuous data formation, we use certain measures for presenting these data. And also it depends whether it is normally distributed or there is a non-normal distribution. All these things will be covered in this session. Okay, so I will just quickly go through this session because next we will be having the hands-on on all these concepts which I will be covering in this session. So I request all the participants to kindly mute yourself. Okay. So to start with, why we want to test this normality? What is the ultimate purpose? Why not we can just directly go with any of the statistical tests? Because before doing any of the statistical tests, there must be a prerequisite. That is, we have to check whether our data is normally distributed or not. Because most of the statistical tests, at the background, they have an assumption that the data is normally distributed. And the softwares are also programmed in such a way that to test the data, and most of the softwares or most of the tests that we use will be applicable only if our data is normally distributed. But if even though our data is not normally distributed, there will be a counterpart, okay, for each of the statistical tests. Okay, so that also will be covered in the later part of this workshop. Okay, so post lunch session, we will be dealing with the statistical test, the parametric test, which we use for if the data is normally distributed, and the non-parametric test. We will go for these statistical tests to check if check the p-value and all if our data is not normally distributed. Okay, so first purpose is that, as I told, majority of our statistical tests assume that our data is normally distributed. And also to determine what measure to use for presenting our data. Say, for example, if our data is normally distributed, we can use or study it in the form of mean and standard deviation. Whereas if our data is not normally distributed, we go with an alternate measure, that is mean, and even we go with interquartile range instead of standard deviation. Okay, so that will be the ideal measures if our data is normally distributed and non-normally distributed. And also to determine the type of test. As I told, each statistical test is applicable based on some underground characteristics. Okay, so if based upon what is the type of data, or based upon how many categories we have or how many groups we have in our variables. Okay, and based upon whether they are normally distributed or not, and whether they are paired or unpaired observations. Each concept will be dealt in the further sessions. But here I just want you to introduce that normality testing is done, or it is a prerequisite before going with any of the analysis. Let it be a descriptive analysis or let it be an inferential statistics. Okay, so everything is based upon our normality testing, or this is the first thing you do after importing your data into SPSS and checking for all the outliers, missing values, and all the coding and all. After doing everything, the first kind of thing which you want to do is to test the normality. And one thing I want to stress here is that it is done only for continuous variables, or also known as quantitative variables. Only quantitative variables we check for the normality. We don't go with checking the normality in case of qualitative variables like categorical and say be nominal, like male, female, or let it be ordinal. Okay, so the socioeconomic status or disease category, mild, moderate, severe. Okay, so if it is in such a categorical or in the qualitative variable type, you need not check the normality. Normality testing is only done for continuous variables. Okay, so please remember this important thumb rule. Okay, so what is this normal distribution? So in day-to-day practice, what we actually do is that we have a research question in our mind, and based upon our research question, we tend to choose our study population, right? Okay, so not everyone in the overall total population we will be studying. We will be choosing only the representative samples because it is humanly impossible to study everyone in the total population. Okay, so we won't be having adequate resources in the form of material, manpower, money, time also will not be possible. Some logistic issues might occur. So we can't study the entire population. We used to choose only the representative samples from the entire population on whom we will be doing the study. Okay, so if the data which we have collected from the samples, if we just transform the data into a form of a curve, if the data follows a normal distribution, we will be getting a symmetrical bell-shaped curve. Okay, so if the curve looks like this, okay, so this is a symmetrical bell-shaped curve. If our data is normally distributed, we will be getting this symmetrical curve. In this curve, there are certain characteristics you have to note. The curve extends from infinity to infinity. You won't see that the curve touching the bottom line. Okay, so it will extend from infinity to infinity, and it is symmetrical. Okay, so if you cut at the center, you could find two identical halves of the curve on both the sides, and you could see that mean, median, and mode, everything will be equal if our data is normally distributed. And also one more concept that you want to know is that what is the standard deviation and standard error. Okay, so if the data is normally distributed, the standard deviation as well as the standard error will be very much minimal. Okay, so what is the standard deviation? So if our data is normally distributed, or if the sample measures we are plotting it in the form of a curve, you could see that majority of our data points are at the center, or there is a tendency for them to cluster at the center. Okay, so that is at the center we will be having the mean. But not all our data points will coincide with the mean. Okay, so some might be somewhat deviated from the mean. So this spread of our data from the mean, or the deviation of our data from mean, is known as standard deviation. And this you are studying only in the sample that from which we have done the study. This is known as standard deviation. Standard deviation is just a measure of variability or spread of our data from the central mean. Okay, so this is standard deviation. What is this standard error? Standard error is a concept which we to look into the population. Okay, so we have studied only the sample, but we have something called as a population. Okay, so we have studied the sample, so the mean which we will be getting from the sample will be known as the sample mean. But exactly there will be a mean in the population, right? Okay, so actually that is known as the true population mean. So how much this sample mean is deviated from the population mean, that concept is studied using the standard error. Okay, so how much our sample mean is deviated from the population mean. Not only one sample. I have studied a subset of a sample. Some other person might study a subset of a sample, or I myself will study a different subset of samples in a later part. But all has been chosen from the same population. So for each of this observation, okay, I might get one sample mean. If the sample means are plotted against a curve, and if you could see the deviation of this from the population mean, that is the concept of standard error. Okay, so just understand that it is a concept we infer on the population. So how much this sample mean which we have studied or got from studying the sample is deviated from the originally the mean that would have been existent in the population. Okay, so how close that is this standard error. Okay, so if the data is normally distributed, as majority of our data points will be towards the center only we have the mean. So the standard deviation as well as the standard error will be minimal if the data is normally distributed. Whereas it will be exact opposite if our data is not normally distributed. Okay, so as I told, majority of the observations will cluster around the central P. Okay, so and the curve will be a bell-shaped symmetrical curve where mean, median, and mode will almost be same, all be same. Okay, and standard error as well as the standard deviation will be minimal if we have a normal distribution. Okay, so what is this rule of thumb? Okay, so before going into any of the statistical tests, we ourselves can detect whether our data is normally distributed or not based upon the calculation of the mean and the standard deviation alone. Okay, so the thumb rule is that if a data is normally distributed, mean, median, and mode, all the three will coincide or all the three will be equal. And second thumb rule is that the standard deviation will be less than half of the mean. Okay, so this is what the thumb rule which we use. And I think in the previous session, Sir has told you, okay, so this 1 standard deviation, 2 standard deviation, maximum till 3 standard deviation, we can have our data that the extreme values. So one, if beyond that, if it is going, they are known as the outliers, as Sir has told. And majority of our data points will lie between the -2 standard deviation to +2 standard deviation only. That is 95% of our data points will lie within this -2 to +2 standard deviation only. Okay. So I hope you have understood this characteristics of normal distribution. Okay. So next, moving on to what is skewed distribution, the exact opposite of this. Okay. So the curve will not be symmetrical. Okay. So the curve will be somewhat skewed like this. Okay. So the central one, which the graph shows the normal distribution, where you could see a symmetrical curve. It is identical. Both the half of the curve, if you look, is identical, and center point, that is the mean, median, and mode, are equal. Okay. Whereas if you say see other two graphs, okay, so at the right of and at the left of, if you could see, the graph is somewhat non-symmetrical and it is deviated to either right side or left side, and you could see that mean, median, and mode, everything is different. And always, if our data is not normally distributed, that is, if our data is skewed, mean will be moving towards or deviated towards the side of the skew. Okay, so we can identify that side of the skew based upon looking into this tail. Okay, so at the end, you could see that the tapering end, that is the tail. Okay, so if normally distributed, the tail will be in this manner. But if it is a non-normal distribution, you could see that the tail will be deviated, or there will be a flattening of the curve and it will be moving towards either of the side. And based upon the tail, whether if it is towards the right side, it means right skew. If the tail is on the left side, it means left skew. Okay, so our data, the direction of our skew also you can identify by looking into this graph itself. Okay, so this by looking into this curve, we can pick it up whether our data is normally distributed or not, and whether it is skewed. If it is skewed, what is the direction of skewing, whether it is right side skewed or left side skewed. Okay, so these things you can just pick it up. Okay, so till now what we saw is that what is this normality testing, why we want to do this normality testing, how will be the normal distribution graph, or what are the assumptions or rule of thumb in case of normal distribution, and what is it in case of non-normal distribution, that is the skewed distribution. As you could see, in skewed distribution, mean, median, mode will not be same, and the difference between and the standard deviation as well as the standard error will be maximum, as the points are not, as majority of the study points or data points which we have collected is not clustering towards the center, because it is deviating, right, either to the right side or to the left side. So this standard deviation as well as the standard error will be maximum in case of skewed deviation, skewed distribution. Okay, so that is why we have various tests to check for this skewness and to look for the statistical significance if our data is skewed and all. We have various statistical tests which will be dealt in detail in the post-lunch session. Okay. So next doubt or next thing which we want to know is that how to test this normality. Okay, so we have seen that we have to test the normality because most of the other analysis, either it could be the descriptive or it could be the inferential statistics, everything needs a normality testing to be a prerequisite, because based upon that only we will be applying each of the measure or each of the statistical test. So how to test the normality or normality test? We have two ways by which we can test the normality of our data. So we have, one is the numerical measure, second one is the graphical measure. Numerical measure, it is also known as objective measure, and the graphical measure is also known as the subjective measure. As graphical measures are subjective measures, there is a chance for subjective variation, because by looking into the histogram, not everyone can pick it whether it is normally distributed or non-normally distributed. Seeing at the first instance or seeing once or twice, you can't pick it up. Okay, it is something which we just gain by experience only. Okay, so expertise is needed to look into this graphical methods to give the conclusion whether it is normally distributed or not. Okay, so that is why there might be some kind of a subjective variation. That is why it is known as subjective methods. And I might say by looking into the histogram as the data is normally distributed, but some other person might say it is not normally distributed. Okay, so if we have a doubt, then we will be moving on to the numerical test for checking the normality. Okay. Do all these tests to look whether my data is normally distributed or not. It is not a hard and fast rule that you have to go with each of these measures to look into the normality of our data. It will be ideal if you go with any one measure of numerical and one measure of graphical. Okay, most of the times what we do is we go with this Shapiro-Wilk Kolmogorov test in the numerical method and histogram in the graphical way, or QQ plot in the graphical method we use to test the normality. And in SPSS, if you just give, there is an option to check normality with statistical test. If you just click that option, you will be getting both the values, Shapiro-Wilk value as well as the Kolmogorov's, that is Kolmogorov's Smirnov's test, KS test, we quite commonly use. Okay, so that both the test values will be given if you just click the option for normality testing in the SPSS. Okay, so the numerical methods quite commonly used are the Shapiro-Wilk, KS test, skewness, and kurtosis values. Skewness value and kurtosis value. The graphical way, we have this histogram, QQ plot, stem and leaf, and box and whisker. In addition to this, there are various methods. Say, for example, in graphical, we have the PP plot. Okay, so in numerical method, we have other tests like Anderson-Darling test and all. But quite commonly, what we are using is these things to test the normality. Okay, so just remember few things, it will be easy. Okay, so either Shapiro-Wilk or Kolmogorov and histogram, it will be enough for you to give a inference whether our data is normally distributed or. And you could see that I have mentioned that Shapiro-Wilk test n less than 50 and KS test n more than 50. What does that infer? So the ideal test to use if our sample size is less than 50 to test for normality will be the Shapiro-Wilk test. And ideally, if the sample size is more than 50, the ideal test to use will be the KS test, that is the Kolmogorov-Smirnov test. Because we have seen certain instances where if the sample size is very large, say for example 500 or 1000, in those scenarios, if we just applied the Shapiro-Wilk test, we would have got a different value in Shapiro-Wilk and in KS test. KS test might show a normal distribution, whereas Shapiro-Wilk might say a non-normal distribution. So in order to avoid these confusions, we always tend to go with Shapiro-Wilk if the sample size is less than 50 and KS test if the sample size is more than 50, because these are based upon the statistical assumptions. Okay, but in practice, what everyone does is totally different from what we have to do based upon the statistical assumptions and all. Okay, so many even go with chaperone if the sample size is more than 50. Okay, so unless you are not getting the same thing in both the tests, okay, so you have to just look into which test to apply for your sample size. Okay, so next I will be just highlighting on each of this test in the further slides. I won't go in depth into all the statistical calculations and all. Just you want to know what we are doing in Shapiro-Wilk test, what is the assumptions that we are using, and how to interpret the value of Shapiro-Wilk test. If you know this, it's enough. As I told at the starting itself, as a clinician or as a researcher, we tend to always look for the interpretation only. Okay, all the test interpretation and inferences are the things that we are very much worried rather than all these statistical calculations. Okay, so the basic assumption in Shapiro-Wilk test is the null hypothesis itself we are fixing as the data is normally distributed. Okay, so here please be attentive in case of the tests for normality, let it be Shapiro-Wilk or KS test. The null hypothesis we will be fixing as data is normally distributed, whereas it will be exact opposite of that association, the testing of the hypothesis or for doing any of the statistical tests for testing the association between the exposure and outcome variable. Where we have fixed the null hypothesis as there is no association between the exposure and outcome variable. That is what the hypothesis we use while testing for the association. But null hypothesis is that it is normally distributed. The data is normally distributed. So next, we go with this p-value. Okay, so if you just apply this test, we will be getting a p-value. And if the p-value is greater than 0.05, then only we can be sure that our data is normally distributed. Unlike in various tests where we are very much worried, or many of the clinicians, they just ask for the p-value less than 0.05. Okay, or majority of them just are very much obsessed with this p-value, and they always ask it should be less than 0.05. But in case of normality testing, only if our p-value is more than 0.05, then our data is normally distributed. Okay, so and as I told earlier itself, it is suitable for sample size sample size less than 50. Okay, so these are the things that we want to do or know regarding Shapiro-Wilk. Next, moving on to skewness. What is this skewness? So skewness is the measure of symmetricity of the curve. How symmetric the curve is. That is what we measure by. So not by merely looking at the graph, we are commenting that it is symmetrical. We will be having a measure. The skewness will be measured in a value. There will be a numerical value. Based upon that, we will tell whether our data is normally distributed or not. And whether it is right skewed or left skewed, okay, whether the symmetry of the curve is deviated towards the right side or towards the left side, we will be looking at. And we tend to say the data is normally distributed whenever the skewness value is between -2 to +2. Okay, so please remember, it is not based upon the interpretation of the curve. It is based upon the numerical value, that is the skewness value. It has to be between -2 to +2 to say that our data is normally distributed. Okay, so next is this kurtosis value. What is this kurtosis value? So it is the measure of peakness of the curve. So how height the curve is, whether our curve which we have got is very much higher of height than the normal distribution curve, or it is of less peak than the normal distribution curve, we look for those in this kurtosis value. Okay, so if our curve is more peak than the normal distribution curve, it is known as leptokurtic, and if our curve is less peak than the normal distribution curve, it is platykurtic. Okay, so same as skewness value, this kurtosis value also has to be between -2 to +2 to say that our data is normally distributed. So in skewness, we are looking with only the symmetricity of the curve, whereas in case of kurtosis, we are looking the height or peakness of the curve. Okay, so just understand the underlying concepts alone. Okay, so here in this diagram, you could see the skewness and kurtosis. Okay, so skewness is how symmetric our curve is, and kurtosis is how peak our curves. Okay, so if we have such a kind of interpretation, if our skewness value is less than 0, then we can say there is negative skewness. If our skewness value is greater than 0, say for example 0.1, 0.2 up to 2, if it is there, we can say there is positive skewness. Okay, and same way for the kurtosis values also. You need not worry about these things. Okay, so positive skewness, negative skewness, we don't want all these informations on the, we just want to look into the skewness value and kurtosis value. If it is within -2 to +2, it means the data is normally distributed. If it is either less than -2 or if it is greater than +2, it means our data is not normally distributed. Mainly if we have so much of outliers in our study only, our data will be in such manner. Okay, so next going on to the going on to the KS test, or also known as Kolmogov's-Smirnov's test. It is same exact of the Shapiro-Wilk test, but the underlying assumption is that it is suitable for a sample size of greater than 50. Okay, so same null hypothesis we will be fixing as data is normally distributed, and we will be checking the p-value. If the p-value is greater than 0.05, we accept the null hypothesis. So the null hypothesis, the data is normally distributed. Okay, so that is what we give based upon this KS test. Okay, so till now what we have saw is the numerical test that we can use for checking the normality. Okay, so we have 4 commonly used measures. One is this Shapiro-Wilk test, KS test, that is Kolmogorov-Smirnov test, then skewness value and kurtosis value. Okay, so in KS test as well as Shapiro-Wilk test, what we assume is that the null hypothesis itself we will be fixing as the data is normally distributed, and if p-value is greater than 0.05, we are very much sure that the data is normally distributed. But Shapiro-Wilk sample size less than 50, KS test sample size more than 50. The skewness is the measure of the symmetricity of the curve, whereas kurtosis is the measure of peakness of the curve. It has both the things should be within -2 to +2 to give that the data is normally distributed. Right? Okay. So next we will be moving further to the graphical methods. So commonly used, as I told, is this histogram. Okay, so histogram, we commonly use it as the way of presenting the continuous variables. Okay, so if we are plotting the histogram and if you are just joining the data points in the form of a curve, if our histogram is symmetrical, then we can say the data is normally distributed. Or if it is skewed, okay, so always for identifying the skewness, look for the tail. Okay, so whether there is a tapering or flattening of the curve, and look for the direction of the tail. Okay, so here you could find that the data is skewed in the second picture and the direction of the tail is towards the right side. So we can say there is right skew. Okay, so this is how we interpret the histogram. It is just by looking at the histogram, we can give the conclusion. Okay, so next is one plot that is known as the QQ plot. What is this QQ plot? The other name for it is the quartile plot. What is this quartile? Okay, here I want to introduce into the concepts or introduce into the terms like percentile, quartile, quintile, and decile. Okay, so what we usually do in the practice or the statistical thing is that all our data points will be arranged, okay, so into 100 equal parts. Okay, so if we divide this 100 equal parts into 25 in one as 4 equal parts, 25, 25, 25, 25. Likewise, we divide our data points into 4 quadrants like this. It is known as quartile. Okay, so Q1, Q2, Q3, and Q4. So the first 25 that will be the 25th percentile. So Q1 means 25th percentile. Q2 means 50th percentile. Q3 is 75th. Likewise, we divide the data points into equal 4 halves. Then it is quartile. If we divide the data points into 5 equal halves, okay, so 20 in 1, 5 equal parts, that is known as quintile. And decile means 10 equal points. So 1 10 percentile, next 20 percentile, 30 percentile, like that into 10 equal halves, that is known as decile. Okay, so you don't want to go in depth into these things and all. Just remember that there is something called as quartile, where all our data will be divided into 4 equal halves. Then it is known as quartile, because quartile only we will be quite commonly using, because for this QQ plot also we will be learning about this quartile, and for interquartile range also we need to know about this quartile. Okay, so what is this QQ plot? Okay, so it is again a graphical presentation. So if we plot all our data points into a diagonal line, okay, so it will be, we'll be having one black line that is known as the diagonal line. Okay, so we will be plotting our data points. What is the observed measure versus what the measure we are expected. Okay, so we will be plotting it, and if all our data points or majority of our data points lie within this line, okay, or coincides with this straight line, that is the diagonal line, it means our data is normally distributed. Whereas if you could see that majority of our data points is not in line with the diagonal line, okay, so either it is above or it is below, then it means the data is not normally distributed. Okay, so if majority of data points is above the diagonal line, it means positive skewness. If it is below the diagonal line, it means negative skewness. Okay, so this is QQ plot. Okay, so again, by just seeing the graph, we can easily pick it. Okay, so we ourselves has to decide. Okay, so if there are only few outliers, okay, so only few points where it is not meeting the diagonal line or in line with the diagonal line, we can go with it. But majority of the data points should be within this diagonal line to say a data is normally distributed. And if you are finding it difficult to interpret this QQ plot, always you can go with the numerical methods, that is the Shapiro-Wilk and KS test. Those values you can take it to say whether our data is normally distributed or not. Okay, so we have two measures. We can go with any of these. Okay, so next is this box and whisker plot. What is this box and whisker plot? Okay, so this plot we quite commonly use to just report the outliers. Okay, so as sir has previously told in the SPSS session, so all our data points should be within this -3 standard deviation to +3 standard deviation. If they are either above that -3 or less than this, say above this +3 and less than the -3 standard deviation, those are known as the outliers. Okay, so box and whisker plot is used to report the outliers, as well as we can test whether our data is normally distributed or not. Okay, so the central part, okay, so that in this orange color, yellow color, that is known as the box, and the tail thing that is surrounding that box is known as the whisker. Okay, so we always look into the whisker. Okay, so how much, okay, so if majority of the whisker is in one side, then we can say the data is skewed to that side. Okay, so like here. Okay, so at the center of the box we should have the mean, and this box and whisker plot is used to represent the mean, and we will be calculating something called as median. So we will be calculating something called as interquartile range. What is this interquartile range? So as I have told, standard deviation is the measure of the deviation of our data points from the central mean in case of normal distribution. Okay, so if our data is not following the normal distribution, we have to use one measure, that is the median only. Okay, so because mean will be deviated towards the side of skewing, and the mean is always sensitive to the extreme values. So in case of those, we can't use mean to present the data. Okay, so we always go with the median. Okay, so this interquartile range is the spread of this median to either side. Okay, so same as standard deviation concept, we use this interquartile range for presenting the median. Okay, so interquartile range gives us the spread of our median. Okay, so we can calculate this interquartile range based upon the formula. Okay, so using this Q1 and Q3, we are very much worried about this Q1 and Q3 only while calculating this interquartile range. Okay, so when we go to this other things, okay, so the calculation of this interquartile range, we could see that Q3 minus Q1. Okay, so that is what interquartile ranges. Manually, we can calculate using the Q3 minus Q1, but not always we have to go with this manual calculation. The software itself will give us the value of interquartile range. Okay, so based upon this box and whisker, we can say the data is normally distributed or there is some kind of skewing or present or not. Okay, and most commonly we use it for reporting the outliers. Okay, so next, before going any further, I just want to know whether the participants has understood the things which I have covered till now. So we will just move on with the interpretation part of each of the measures we saw here. Okay, so this is one result which we have got for the age-wise age we have had in one of our study, and the age is distributed in such as a continuous variable, and the Kolmogorov and Shapiro-Wilk test value we have just projected. Based upon this, can you say whether the data is normally distributed or not normally distributed? You can just put in the chat box, or you can just unmute and say whether the data is normally distributed or not normally distributed. Anyone?
Not normally.
Not normally distributed. Why you say so, ma'am?
P is less than 0.05.
Exactly, right. Okay, so I hope that you have understood the concept, because if the P is greater than 0.05 only, we say the data is normally distributed. Here, the P value is less than 0.05. So, the data is not normally distributed. So, in our study, age is not normally distributed. You know, don't want to look into the statistics, that is the Smirnov statistics and the Shapiro-Wilk statistics, and the just you look into that significance, that is the P value. Okay, based upon that, if it is greater than 0.05, it means data is normally distributed, whereas if it is less than 0.05, it is not normally distributed. Okay. Anyone has any doubt in this? Okay, so next we will move on to the next thing. Okay, so in one of our study, we have just found out that the maternal height, distribution of the maternal height is in such manner. Okay, so whether this maternal height is normally distributed or not, you just look into only the skewness and kurtosis values. Look into only these two and just tell me whether it is normally distributed or not normally distributed. Whether the maternal height is normally distributed or not normally distributed, purely based upon the skewness as well as the kurtosis value.
Normally distributed.
Normally distributed, right. Okay, how do you say that it is normally distributed?
Less than plus or minus 2.
Right, exactly. So if the skewness as well as the kurtosis is between -2 to +2, it means our data is normally distributed. So here the maternal weight is normally distributed. So I request all the participants to kindly mute yourself.
And we should check statistics or standard errors.
No. That and all, you just don't worry. Okay, so for testing the normality, we go with either the numerical as well as the graphical measures. Okay, so here based upon the participants, can you please unmute yourself? Sorry, mute yourself.
Hello.
Just a minute.
Hello.
Just a minute, ma'am.
Hello.
Sir, unmute, sir.
Okay. So the participants, please mute yourself. We are getting so much of feedback. Okay. Yes, ma'am.
Hello.
Someone was asking some questions.
Hello.
Yes.
In both the cases, now in both the table you showed mapping and mapping rate and always distributed because
Ma'am, your voice is breaking.
from minus 2 to plus 2.
Yes, your
Hello?
voice is breaking. Can
In
you?
the table you showed just now, in the
Yes, ma'am.
table you showed now, in the table you showed just now, both maternal height and maternal weight are normally distributed because the students are
Ma'am, we are not able to get you, ma'am. Can you just put your query in the chat box, ma'am?
Excuse
Your
me.
voice, your voice is breaking, ma'am.
Hello? Am I audible now?
Yeah, ma'am.
Hello?
Yeah. Yeah, you are
Am I
audible
audible now?
Yeah, you are audible now.
Yes. In the table you just previously, the table you showed, in that
Yes, ma'am.
both maternal height and maternal weight are normally distributed because the skewness and kurtosis value is between -2 to +2.
Exactly, ma'am. Exactly.
-2 to 2.
Yes,
Okay, that will
-2 to +2. If the kurtosis and the
yes.
skewness value is there, it means data is normally
distributed.
Sir, I didn't
Exactly.
get the
-2 to +2
clarification.
is which one, sir? Statistics value or standard error value?
No, statistics value. Statistics value. Just to look into only the statistics value. You don't confuse it with the standard error and all. Okay, so now we are dealing only with the statistics value because this standard error concept and all will be going only when we go for the inferential statistics only. Okay, so now we are just in the phase of testing whether our data is normally distributed or not only. Okay, so please don't confuse with this standard error and all right now. Yeah. Any queries? Any other queries? Am I audible?
Yes, sir.
Okay. So next, moving on to this histogram, right? So what is the interpretation that you can give based upon this histogram? Whether our data
Right
is
skewed.
normally distributed or not normally distributed?
Right skewed.
Yes, exactly. It is right-sided skewed. Our data is skewed, and we can identify the side of skewing by looking into what is the tail. Okay, so the tail, whether it moves or deviates to the right side or it deviates to the left side. Based upon that, we can say that our data is skewed. Okay, so just a minute. Okay. Sorry for the break. Okay, so we will just move forward. So next, as you all correctly pointed out, this histogram is skewed and it is skewed towards the right side. So next, based upon this QQ plot, okay, so what is your inference? Whether it is normally distributed, the data is normally distributed or not normally distributed?
Not normally distributed.
Yes, not normally distributed. Why do you say it as not normally distributed, ma'am?
Not along the straight line.
Yes, not along the diagonal line. You could find that majority of the data points are not in line with the diagonal line and they are lying outside the diagonal line. Okay, so here we can say that the data is not normally distributed. Okay, so I hope all of you have understood this. Yes,
Sir, I have a doubt. On the previous graph, that QQ plot now. So
Yes,
how
ma'am.
will we interpret it? Is whether it is positively skewed or negatively skewed?
Okay, so that point is not needed at this moment, ma'am. Okay, so we want to just look into, let it be right skewed or left skewed. We are not bothered about that. Okay, so because all the statistical test which we use is not going to be based upon the right skew or left skew. Okay,
No, sir.
so just we will be going with whether it is skewed or normally distributed. That's it.
No, sir. My query is like that. How will we interpret it? Whether it is bit this skewness, it is interpret on based on highest point, where this highest point lies, or depends upon a more number of data point lies below or above the line. How will we
based upon whether majority of our data point lie within the diagonal line, we say normally distributed. If majority of our data points is above the diagonal line, we can say positive skewing. If majority of our data point lie below the diagonal line, we can say negative skewing. Here mostly it will be a negative skewing only in this picture.
So we can sir comment here. So we can comment. So we can sir comment here. Okay, most of our data variables are below the mean of the mean age.
Yeah,
Right?
please, can you just ask the question, sir, once again?
So from this QQ plot, we can say like that most of our data variables or the study participants are below the mean age.
Okay.
Can we comment on like this?
No. That and all we can't comment it by going with the QQ plot. Okay, so we just do the QQ plot only. One thing, that is whether our data is normally distributed or whether there is any skewness or not. And if the skewness is there, whether it is positive skewed or negative skewed. Okay, so that is what the interpretation we can give based upon this QQ plot. Okay, so if there are no further queries, I think I assume that you have understood, and we will just move on further as we are very much running out of running over the time. Okay, so next will be the descriptive statistics. So next I come to the second half of my session, that will be on descriptive statistics. What is this descriptive statistic? What is descriptive statistics? What is analytical or inferential statistics? What is the difference between these two? We want to know. So basically what, as I have told earlier itself, what we tend to do in any of the research is that we first identify our research question, then we choose the population, right? Okay, so we are not going to study the entire population, as there is no logistical possibility, and also resources will not be adequate to study the entire population, and it will be time consuming. So what we do is we just select the representative samples from this study population, right? So we tend to select only the representative samples from this study population. Okay, so we will be studying those samples and we will be giving the conclusion based upon the samples. Okay, so if we just stop with this, okay, so just studying the samples and giving the conclusion. Okay, so this is what the finding I have found out in my study. Okay, so just we are going with only the descriptive thing without testing the hypothesis or without going with the testing of association, then it is known as descriptive statistics. We are just describing about our study variables. Okay, so that is why this descriptive statistics are also known as summary statistics. We are just summarizing our findings into a meaningful way. Okay, so we can either use a table or either it could be a graph or a figure by for presenting this descriptive data. Okay, so that is what we do in descriptive statistics. We are not going to test the hypothesis or we are not going to test the association between the exposure variable that is known as the independent variable as well as the outcome variable that is known as the dependent variable. We are not going to test any association. Okay, so if it is what the scenario is, we are not going to test. So we are not going to give any inference about the population. Okay, so what the sample findings we have found out, if we are generalizing it and giving the extrapolation of our sample results to the total population, then it becomes inferential statistics. If we are just staying with reporting of what our study results are, we just stop with it. We are not going with studying the association between the exposure and the outcome. We are not testing the hypothesis. So we are not getting any measure of association. Say, for example, the odds ratio, relative risk, the prevalence ratio, everything we will be getting only if we test the association. Only if we have this any kind of association testing, p-value or this measures of association, then only we can comment about the total population based upon our study result. Okay, so if we are not going to generalize our study result, we are not going to extrapolate our study result to the population, then it is known as descriptive statistics. As we are not going to test the hypothesis in case of descriptive statistics, there won't be any kind of an uncertainty. And we are not going to calculate the confidence interval and all in case of descriptive statistics. So there is no uncertainty about it. Only if we just extrapolate our result or generalize our result to the total population, we have some kind of uncertainty. Okay, so that is one of the, again, the limitation of this descriptive statistics. We are not going to give any kind of inference. We are just sticking on with the sample measure alone. Okay, so that is known as descriptive statistics. Okay, so this is what we do. We study the population from which we choose the samples, and we will be framing the hypothesis and all in case of descriptive studies, but we won't be testing it. If it is tested, it becomes an inferential statistics. Okay, so we calculate the odds ratio, relative risk, prevalence ratio, and based upon that we extrapolate or give the conclusion to the total population, then it becomes inferential statistics. But if this part is not done, it is only a descriptive statistics. Okay, so what are the characteristics of descriptive statistics? Only you describe about the sample. You are not going to infer about the population. You're not going to do any of the hypothesis testing and all. Okay, so we won't be framing the null hypothesis. We won't be framing the alternate hypothesis. We won't be testing anything. We will be just giving the descriptive informations. Okay, so say for example, the count frequencies, percentages, the prevalence, mean, standard deviation. These are known as the descriptive statistics measure. Okay, so next moving on, what are the various types of descriptive statistics? So we have nearly 4 measures for descriptive statistics. One is this measure of frequency known as count, presented as count or percentage. Next is the measure of central tendency, where we have this mean and median. Quite commonly we have other measure that is the mode, but it is not commonly used for assessing this giving this descriptive statistical inferences and all. Next, the measure of dispersion, that is the spread, how our data is varied from the mean, that spread of that data or data from the mean, the central measure, that is known as the measure of dispersion or variability. We use range, interquartile range, and standard deviation for presenting this measure of distribution. Last we have is the measure of position, that is the percentile and quartile.
With me, can you show the previous slide about descriptive, the 3 points? Can you show it again?
Yes, ma'am. So descriptive statistics, we have 3 characteristics. One is we infer only about the sample. We describe only about the sample. We are not going to infer about the population, and we are not going to test the hypothesis. Okay, so these 3 points, if you remember, it is enough about this descriptive statistics. Okay. So I hope you have understood. Okay. So moving further, as I told, these are the 4 measures. We will be seeing each measure in the subsequent slides. So first is the measure of frequency. Okay. So just by count or just by giving the percentages, we go with this measures of frequency. Just a minute. Okay. So based upon this frequency, the measure of frequency, we just tend to give it in either in the account or we tend to give it in the percentages. Okay, so that is what we do.
Unmute, sir.
Yes. Okay. Sorry for the interruption. Okay. So moving on to the measures of frequency, we tend to use either the count or we go with the percentages under. Okay. So we can use either the frequency table or a graphical way of presenting the data. Either you can use the histogram if it is a continuous variable, or if it is nominal or ordinal, we can go with the bar diagram under. Okay, and we have this percentile where we have this quartile, quintile, decile, and all. Okay, so these are the ways by which we just present the frequency. Okay, so the first thing, or the first table in any of our study, we will be having the socio-demographic tables. Okay, so there we tend to give this frequencies and percentages. Okay, so that is one way of putting the descriptive statistics. Okay, so next, moving on. Is this measure of central tendency. Okay, so if our data is normally distributed, what it usually happens, as I told, all these measures, okay, so we will be testing whether, sorry, if our data is normally distributed or in regular practice, what happens is that majority of the data points, okay, so will be clustering towards the center, or they have a tendency to be in the center. Okay, so this tendency of the data points is known as measures of central tendency. Okay, so this is known as audience. Yeah, audience, please unmute your, sorry, mute your audio. Okay. So the measures of central tendency, as I told, majority of our data points will have the tendency to cluster around the center if it is a normal distribution. Okay, so the commonly used measures for assessing this thing is the mean and median. Okay, so mode also we can use, but it is of lesser use in giving any kind of a statistical inferences and all. So we are not going with the mode here. We just stick on with mean and median. That is enough. Okay, so what does this mean? Okay, so I don't want to go in depth into this basic concept, I guess. So just the average. Okay, so for by mean we mean just we just count all the sum of observations and divide by number of observation. It will give us the mean. If our data set is very small, we can manually itself do all these calculations. But if you are having a large sample size and all, we can't manually calculate it. So we go with the softwares. Okay, so they will be giving us the mean value. Okay, so mean is the way to present our data if it is normally distributed. Okay, so if our data is not normally distributed, we usually don't go with mean, because if it is not normally distributed, the ideal measure, as I told, will be the median, because mean will be skewed or mean will be deviated to the side of skewed in case of non-normal distributions, right? Okay, so that is why we don't go with mean in case of non-normal distribution, but vice versa can happen. Median we can even use if our data is normally distributed. It is not that median only for non-normal distribution. No. Okay, so median and mean can be used for normal distribution, but median only to be used if our data is not normally distributed. Okay, I hope you understood this difference. Okay, so what is this median? Okay, so if we are having a data set which is odd number of observations, so center point you take, that is median. You have to arrange them in the ascending order or in the descending order, and center point if you take, that will be the median. Okay, so if it is even number of observations, so middle average we take it for calculating the median. Okay, so median is the preferred measure to present our data if it is not normally distributed, and if it is skewed, we go with median only. Okay, so next we have just studied the central value. Okay, so next we have to go with the spread or dispersion or variability of our data from the central value. Let it be the mean or let it be the median. What are the commonly used measures of dispersion? Will be the range, standard deviation, and interquartile range. Okay, so what is this range? Okay, so range, simply if I want to tell, maximum minus minimum. Okay, so maximum value minus the minimal value will give us the range. So, but range, as it includes only the extreme values, the maximum and the minimum, it is not an ideal or a reliable measure. It is always an unstable measure to study the dispersion, as it doesn't care about the midpoints. Okay, so what is the data units between this maximum and minimum? Okay, so the center part, it doesn't give any inference about that or take into consideration those values. Okay, so that is why it is not a suitable measure. That is one of the limitation of using the range. But we can just know what is the maximum and what is the minimum and all. Okay, so when we put the table, okay, so where we want to present our continuous variable, say for the example age. Okay, so we used to give us the maximum value, minimum value, what is the mean, what is the standard deviation. That is what we tend to put in the frequency tables and all. Okay, so in the table you can use this maximum or minimum, or else it doesn't have much of a significance in statistics. Okay, so majority will be only the theoretical aspect. Okay, so next moving on to one important measure, that is this interquartile range. As I told, okay, so if we are having so much of extreme values, okay, in our data points, okay, so then we can't use this range as a measure of dispersion. Then we can't again use this standard deviation also as a measure of dispersion. We can go only with this interquartile range. So if we have more extreme values in our study, we can go with only this interquartile range. And if more extreme values, definitely our data will be not normally distributed, and ideally we have to go with interquartile range only. There is no other option. Okay, so but interquartile range also it considers only the Q3 and Q1. Okay, so the quartile 3 and quartile 1. It doesn't consider quartile 2 or quartile 4 into account for giving this inferences. So that is why it is one of the limitation of this interquartile range. Okay, so you need not confuse too much. Okay, so if our data is normally distributed, we go with mean and standard deviation. If our data is not normally distributed, we just go with median and interquartile range. If you know this much, it is enough. Okay, so because at the basic level, we want to know whether our data is normally distributed or not, and we have to give a descriptive measure based upon whether it is normally distributed or not at this moment. Then we will be going with the inferential statistics where based upon all these assumptions, we choose a test based upon if it is normally distributed or not normally distributed. Okay, what is this concept of variance? Okay, so variance is one important measure by which we choose this or we measure this variability. Okay, so what does it mean by, okay, so or how to calculate this variance? Okay, so by calculating the variance only, actually we calculate the standard deviation, because square root of variance will give us the standard deviation. Okay, that is what we want to know it. Okay, so first how to calculate the variance. Okay, so manually how we usually do is, so we say, for example, we are having cholesterol values of 10 individuals. Okay, so we are arranging them. Okay, we are just calculating the mean. So the mean here of cholesterol values for this 10 individuals is 186.6. Okay, next what we have to do is the individual points, how much it is deviated from the mean. That we can assume by subtracting. Okay, so the individual point from mean, if you subtract, we will be getting one value. That is the difference. Next, what we will be doing is we will be taking a square of this value. Okay, as we go with square, this plus and minus signs will not be taken into consideration. Okay, the square values. Next, what we have to do is we have to add the sum of all these square values. That will give you one value. That is known as the sum of square deviations. Okay, if we divide it by the number of samples, okay, so then it is variance. If the sample is less than 30, we have to go with n minus 1 at the denominator. If it is more than 30, we just go with the sample, total number of samples alone. Okay, so in this example, the variance is, we have calculated the squares. Okay, we have the sum of the squares, which is 9542.4. Okay, so total number of observation, we have 10 here. But as the sample size is less than 30, n minus 1 to be used in the denominator. So we get 9. So 1060 is the variance. If we take the square root of the variance, we will get the standard deviation. Okay, but we are not going to do all these calculations. The software itself will just give us. Okay, so if you just click mean and standard deviation, the descriptive measures, next session you will be seeing in the hands-on. Okay, how to calculate these descriptive measures and all. Okay, so at that point, you can just find how to just easily calculate this mean, standard deviation, everything. Okay, so what is this standard deviation? As I told, it is a square root of the mean, and it is the spread of the data from the mean. As I keep on insisting from the starting, we are measuring the deviation of our data points from mean. That is standard deviation. Okay, so and it is one of the very good reliable measure to test the variability unless our data is normally distributed. Okay, so standard deviation, as it has been already told, usually it will lie within -2 to +2 standard deviation, and we have to look whether our data is above 3 standard deviation and below -3 standard deviation. If such a thing is there, it is an outlier, and it is usually denoted using rho. Okay, so the formula and all, I don't want to go in depth, I guess. Okay, so in the previous thing, while calculating the variance itself, I have told you. Okay, so first we go with calculating the mean. Next, how the difference between the mean and our individual data point, that will give you the difference. Square the difference, Okay, then take a square root of this. It will give you the standard deviation. Okay, so all these directly we can go with the software. So here, what is the standard error? Standard error is the standard deviation by square root of n. As I told, standard deviation is a measure which we infer based upon the sample alone. But whereas standard error, we give it for the inference to the population. So how much our sample mean is deviated from the population mean. That inference we give it using this standard error. Okay, so this is not needed. Standard error is not a descriptive measure. Okay, so just for completion sake, I have told you standard error is equal to standard deviation by square root of n. Okay, so if you know this, it's enough. Okay, so next is the measures of position. We have this percentile, centile. Not quite commonly we use it, but we are very much aware. Okay, so in any of the competitive exams nowadays, we are not going with the percentage. Okay, so we go with percentile only. Okay, so percentile is 100. Okay, so 100 is known as 1 percentile. Okay, so if we just divide this percentile into 4 equal quadrants of 25, it means quartile. 5 equal quadrants, it means quintile. 10 equal quadrants, it means decile. Okay, so if you know this, it's enough. Okay. Okay, so next moving on to the last part of my session, that is what type of measures or what type of diagrams we can use for each of the type of variable. Okay, so I won't going in depth into any of this. You just if you have any doubt, you can just always come back to the slide and you can just pick an ideal measure. If our data is quantitative, say for example, continuous variable. Okay, so then the ideal measure or quite commonly what we use is this histogram, scatter plot, stem and leaf, and box plot. These 4 only we quite commonly use. Okay, so the histogram and all, we can either use it for as a descriptive measure or for testing the normality. The scatter plot is where the correlation concept comes in. So in the post-lunch session, you will be learning about what is correlation, what is regression. There you will be shown about this scatter plot and all. So stem and leaf and box and whisker plot, as I told, it can be used for testing the normality of our data. And if we are having only the categorical variables, say whether it is a nominal variable or let it be an ordinal variable, quite commonly used diagrammatic presentation will be the bar diagram. Quite commonly we go with either the bar diagram or pie chart. Okay, so let it be a simple bar diagram or a multiple bar diagram, clustered bar diagram, whatever it might be. Quite commonly we use only 2, that is bar diagram and pie chart. Okay, so if you know this much, it is enough. Okay, so we have reached the end of our session. So before closing, I just want you to just identify what are these 2 pictures that I have just projected. Okay, so I haven't covered these 2 in my class, but just in the further classes and all, you might be knowing these. Okay, so how to do these diagrams and all. Okay, so what is this diagram? Can anyone identify what type of diagram is this?
Bar
So
chart.
this is actually a study which we have conducted among the school-going adolescent children. Okay, so we wanted to study the NCD risk factors prevalence among the school-going adolescent children. So we have chosen participants from both the private school as well as public school, and the prevalence of all these 4 we have projected in this single diagram. So it is what diagram? Can someone?
Bar chart.
Bar chart. Whether it is a simple bar chart or anything else you want to add on?
Multiple.
Is it a multiple bar chart?
Yes.
Right. Okay. So it is a
error bar.
yes, it is actually a clustered bar diagram with error bars. Exactly. One has pointed out beautifully that there is a error bar. What is that error bar? That gives us the 95% confidence interval of our measure, the point estimate. That is the prevalence of the for all these risk factors. Okay, so let it be the tobacco use, alcohol use, unhealthy diet, or physical inactivity. That will give you one measure, that will be the prevalence, and how this prevalence varies from the population. That 95% confidence interval is what at the top you could find the error bar. Okay, so what is the advantage of this clustered bar diagram? Because if we want to put all the risk factors individually, only we can put tobacco use, overall how it is, public school how it is, private school how it is. So it will become 4 individual bar diagrams that we want to put in such a scenario. But this clustered bar diagram has an advantage that in one diagram itself, we could easily combine all these information, and it will be very easy for us to also give the interpretation part. Okay, so this is a clustered bar diagram with error marking. Just if you know clustered bar diagram at this moment, it is enough. Okay, so what is this diagram? Can someone interpret it, or just to give? Because
Scatter plot.
yes, this is again one of the important and quite commonly used diagrammatic presentation, that is the scatter plot. So where we usually go with the scatter plot? For what type of variable we commonly go with the scatter plot?
Continuous.
Exactly. So continuous variables.
Just we remember last.
If both the variables, okay, so if our outcome variable as well as if our exposure variable, that is the independent variable, will be the exposure, the risk factor, quite common. Next, we have the outcome variable, that will be the dependent variable. Okay, so if both are continuous, then we go with this scatter plot and we calculate the correlation coefficient. We test whether there is a correlation, positive, negative. All these interpretations we can give using this scatter plot. We use it when both the variables are continuous. Say, for example, you want to study based upon age, how the BMI is changing. Okay, so age and BMI, if both are, you can know that age is continuous, BMI is also continuous. If you want to compare this, whether there is a association between these two, then we go with the correlation and we just put this scatter plot. And all this interpretation of the scatter plot, everything will be covered in the afternoon session. You need not worry at this moment about the interpretations of these scatter plots and all. Okay, so I just wanted to introduce you into those concepts for the time being. Okay, so I hope I have done justice to the topic, and I have made you clear about what are the commonly used tests we can use for testing the normality of our data, whether it is normally distributed or not, and what is the ideal measure of descriptive statistic we can use for each of the type of data, whether it is a mean, whether it is a median, interquartile range, standard deviation, and what are the quite commonly used diagrammatic way of presenting our data. Okay, so just knowing about these statistical concepts is not enough. Only when we just apply them, it will help us, because we will be getting many doubts, and only if you do a hands-on practice, only you can learn these concepts. Okay, so you need not worry if someone is not able to download the SPSS or install it at this moment, because we will be sharing the video recordings of this workshop. So you can just sit back at your comfortable time, and you can just go through the video and do each and everything in a stepwise manner, so that you can have a very good hands-on thing. Okay, and also if participants are having doubts, at the end of this today we will be giving you some data sets, and we will be giving you some exercises also. Okay, so that you can work it out, and we will give you a break of Sunday. Okay, so in Monday, if you are available at the evening time, okay, so we will be having one more doubt clarification session, where we can just give, if you have done this exercises and all, we can give the comments based upon that. And if you have still more doubts or need any clarifications, we can go with that doubt clarification session also, only if you are interested. Okay, so if there are any doubts, the participants can just ask your doubts. or else we can just move forward. So any doubts? With any of the concept that I have just covered right now?
Hello, sir.
Yes.
Sir, what is the basic difference between confidence limit and confidence interval?
Yes, confidence limit is that ma'am has already covered in the first session, that alpha error. Okay, so that is what you mean by the confidence limit. Okay, so we assume that the result which we have come across is not by chance, or if it is by chance, what is the limit? We usually set it at 5%. Okay, so that is why, that is what the confidence limit is. Confidence interval is what something is based upon the measure of association. Say, for example, for odds ratio, for relative risk and prevalence ratio and all, we will be having the limit. Okay, so the upper limit and lower limit. What is that inference is that? So we assume that in the true population, because as it is an inferential statistics, this confidence interval concept and all is an inferential statistics. We study the sample and give our extrapolation of our study results to the population. So our sample measure, we have calculated one value. Okay, but actually the population might have the similar kind of value only, but it might have some deviations. Okay, so that is what this upper limit and lower limit means. Okay, so we assume, or we give a conclusion or inference that the population, in the population also, our value will be between these two limits only. That is what the confidence interval means. Most of the times we will be fixing it as 95% confidence interval, because we assume that 95% of the times the population value will be within these two limits, the upper limit as well as the lower limit. Okay, so that is the concept of confidence interval. If you need much more clarity on this, in the afternoon session, I will be dealing with this p-value calculation, p-value determination and inferences, as well as this confidence intervals and all. I will be covering it in the afternoon session too. Okay, I hope
in case of a normal distribution, mean, median, mode is equal.
Yeah. Yes. Can you come again?
No, sir. In case of skewed distribution, right and left skew, how does mean, median, mode change?
Yeah, definitely the mean, median and mode will change, right? As I told, the mean will be deviated towards the side of the skew. Okay, so and the mean as well as this median and mode will not be same if our data is not normally distributed. Wait a minute, I will just share my slide once again.
Yes, sir. I just want to know which will be higher value, which will be the lower value. In case of normal distribution, all three are equal.
Yes. As in this, you could see that the mean, median and mode, everything will not be the same in case of non-normal distribution. Majority of the times, if you see, mode will be more. Okay, but we go by median only for presenting our data in case of non-normal distribution, and we can't use mean, as the mean will be deviated towards the side of the skew. Okay, so but mode will be highest. Okay, but we are not bothered about that. Okay, so the highest value and all we are not bothered about. We give our conclusion only based upon our median if our data is not normally distributed. Anything else? Anyone with any other doubts?
So what is effect size?
Yes.
Unable to understand this thing, effect size.
Yeah, effect size. Okay, so this effect size and all, we tend to use it while calculating the sample size. Okay, so what does that effect size mean is that, so as I told, we are studying only the sample only. We are not studying the entire population. Okay, so by our sample finding, we tend to extrapolate our finding towards the population. Okay, so but we can't be always sure that same as our sample, only the population measure will be. Okay, so how close or how it is deviated, that is what we measure by this effect size. Based upon the study design and based upon the sample size, sampling methods which we use, this effect size will be added to our sample size to nullify that effect that our sample might be deviated from the total population. To reduce this variability only, we use this effect size for calculating the sample size and all. Okay, so it depends upon, as I told, depends upon the sampling method we use. Okay, so all our assumption is that if we use simple random sampling, there will be a lesser variability. Okay, so if we go for non-simple random sampling methods only, we tend to use this effect size much more. Okay, so it reduces, it will reduce the chance that our sample measure that we have got will be deviated from the population measure. Okay, so that is what effect size means. Anything else?
So can you explain that bar chart, sir? Or how can we find, so should we find that error?
Yes, ma'am. Bar chart.
How we supposed to find that error? It's an error bar chart.
Okay, error bar diagram. Okay, so it is not because it is not quite commonly we use this diagram. We just go with this go with the clustered bar alone. But what does this error diagram means, or the error marking, what does it signifies is that, okay, so let us take the first thing, that is the overall. Okay, so both the public as well as private schools combined, what is the prevalence of 4 things we have? Okay, so physical activity, tobacco use, alcohol consumption, and unhealthy diet. Okay, so the top of that bar, that is what we give you the estimate, that is the prevalence will be at the top. Okay, so say for example, the prevalence of physical activity is around 70, above 70%. Okay, but this error marking, what does it indicate? Okay, so it indicates the limit or the confidence interval, though that in the total population, that is actually the population from which this sample we have chosen, in that population, the prevalence will vary from this to this. That is what this 95% confidence interval is. That is what it's been given using this bar, error bar. Okay, so it will be around, say, for example, here you could see it is below as well as it is above. Okay, so say, for example, it might vary from around 68 or so to 73, 74, likewise. So here, our prevalence in our study is, we have got 71 or 70 as such. But in the total population, there will be a true measure. Okay, so that we can't find it out. But we assume that it will be within this range only. That is what this error marking or error bar indicates. It is not a common practice to use this error bars. It and all, it is an advanced thing, or if the journal just insist, we can go with it, but majority of the journals won't insist with this error bars and all. Okay, so it is just a kind of a gimmick. Okay, so if you just add error bars and all, we are just projecting that we know many things and our results are in such a manner. So it is quite easy for the reviewers, and also there is more chance if we use such kind of diagrammatic presentations in our manuscripts for it to be accepted in reputed journals. Okay, so that for that purpose only, we just go with this error bars.
Thank you, sir.
Yes.
Error
Anything
bar
else?
means, hello, error bar
Yes,
means, error bar means how much the population mean deviates from sample mean.
yes. It is not as such a
So
mean here.
error means
It is just a population estimate. Okay, so because we are dealing here with prevalence, mean and all will be for continuous kind of variable only. Here our variable itself is a categorical, but what inference or what interpretation you have given is exactly the same. Okay, so in our sample we have got one prevalence. Okay, so how much our prevalence will vary within this interval only in the total population. That is what we give by this error bar, or the limit, the upper limit and the lower limit within which the prevalence of the this risk factor will be in the total population. That is what we mean by this error bars.
So, sir, are we representing then standard error using this error bar? Standard error.
Yeah, but standard error is mostly it is for the continuous variables, ma'am. Here we are mostly dealing with the categorical variables only, because the estimate here is a point estimate only. Okay, so prevalence only we are doing it. So in this error bar, we just go with this prevalence only in this scenario. But standard error also can be used if it is a continuous variable also.
Sir,
Yes.
how can we make this type of error bar using SPSS? We can make.
Yes, ma'am. It is advanced. I think yes, you can do it in SPSS. Whether it will be covered in this workshop, I am not sure about it. But you can do it with the SPSS, ma'am. Definitely, you can do it with the SPSS. This error bars and all can be done. Cluster bar diagram with error markings can be done.
Okay.
Okay, I hope there are no further queries. And if there are any further queries, you can just put it in the chat box, or it will be ideal to put it in the WhatsApp group. It will be answered by any of the resource persons, or it will be answered by me if it is pertaining to my session in the afternoon session, because we are running very late, and we will go on with the next session that will be on the hands-on session on the descriptive statistics as well as the normality testing.
Thank you, Dr. Vijay Karthikeyan.
Yes,
So I have just added two files in the chat box. Okay, it's a .sav extension. So I please open that in your SPSS. You'll have already installed the software, I'm told. So you can just open that. Just open the first one, which is vaccine.sav. So I think in the previous session, we've done an excellent in-depth session on descriptive statistics. So what I'm going to do is the theory behind it and how to infer it, everything has been covered. So you basically only need to know what button to click to find that value. That's the only part that's pending. So let's try to quickly do that so we can also catch up on some time.
Ma'am, can you
Yes.
please put that in the WhatsApp group?
I will reshare it 1 minute.
Thank you.
Oh, you want me to put it in the WhatsApp group, is it?
Yes, ma'am.
Just put it in the chat box. I'll try sharing it in WhatsApp also.
Thank you.
So I've shared two files on the WhatsApp group also. I'll be working with you on the vaccine, the folder, the file that's called vaccine.sav. The other one you can use to later try out. Okay, it has some information in it. Shall we start? Okay. Can I share my screen? Yes. Is my screen visible?
Yes.
Yes, ma'am.
Have you all been able to open this same file? Are you all able to open this file? So if you let me know, we can decide, we can go ahead and quickly complete this. Have most of you been able to open this? Okay, so I'll just quickly start. Okay, so what we are going to do is, this is how the variable view looks. You've already been introduced to the data view and the variable view. So I've put in a limited number of data variables here. Okay, since we are only going, we are literally just starting the analysis part, and we are looking at descriptive statistics. So the first thing I want you to be able to understand is, go to variable view, please. So we have a list of 13 variables. Out of this, can you tell me, can you name the quantitative variables from here? Anyone? Because what summary measure we want to do for the variable depends on whether it is qualitative or quantitative. Can anyone tell me, is age quantitative or qualitative?
Quantitative.
Quantitative. What summary measure? Yes, quantitative. What summary measure can we use? So the easier way is to actually just think in terms of what answer we are going to put in our paper. Okay, so when I write my paper, when I want to describe my population parameter, I'm going to say things like, the mean age was, or the median age was. So if it is you think it is very complicated, or you don't identify with thinking in terms of, is it qualitative, then I will go with this, or is it quantitative, then I do that. And just think what your result is going to sound like. So you know that mean is quantitative. For quantitative measures, we are not going to go for counts or frequencies or proportions. No, unless I want to say things like, this percentage of my population is below 60 years and that percentage is above 60. Then I can go for counts. But now what I want is, I want to summarize my population in terms of what is the mean age or the median age, right? So can you all quickly tell me what are the measures of? So you all just had a very in-depth session. What are the measures of central tendency?
Mean, median, and mode.
Mean, median, mode. So let's just quickly see one click of a button and how you get mean, median, mode. So when you open SPSS, you have an output document that gets generated like this. Whatever calculations you do will come onto your output document. So I am going to, today in the descriptive section, you can see there's an analyze here. Yes. So when you click on the analyze in descriptive statistics, that is my second option. I'm going to show you something with frequencies, with explore. Okay, now what you will find is, you will find a repetition. Okay, in multiple places you will be able to calculate mean, median, mode, sums, quartiles, percentiles, everything. Okay, wherever you calculate it, be the same. You're going to get the same answer. It's not going to change. Okay, the calculation, the mathematical part of it is going to be correct. Okay, there will be slight differences. Like in one tab, you might not be able to calculate a whereas you might with another. So let's start with frequencies. Okay, so I open frequencies. Okay, so these are the variables on my left. Okay, now I want age. Okay, so we decided we want measures of central tendency. I'll do this again slowly. Okay, so these are my variables. Okay, and I'm just moving age to the box on my right. Okay, once it's here, I click on statistics. When I open statistics, you see a box, right? Multiple boxes here. This on the right are measures of central tendency. I have clicked mean, median, mode. Here I see percentile values. Below that, measures of dispersion, and right is distribution. So in distribution, it's going to show you skewness and kurtosis. So I'm going to take out all this. Let's first just quickly take a look at measures of central tendency. Can you all do it and see the output? Before I do it, can you all see the output quickly and tell me what is the mean, median, and mode you all are getting for the age variable? You can even put it in the chat box. What is the mean, median, and the mode? So all of you are getting the same means? Yes. So now I'm going to press continue. Okay. And let me see what happens. So here I have display frequency tables. Okay, so what it does is it will tell me exactly how many people are there in the 16-year age group, how many are there in the 17-year age group. Right now, it does not make sense to me. I don't want it. I'm unchecking it, or I can even leave it, no issues. Okay, so did you all get a box like this? Okay, so now I'm just going to teach you what these words mean on the box. Okay, n is my sample size. I have 100 data for age. I have no missing variables. So I have age for all 100. The mean is 31.03 years. The median is 25 and the mode is 18. So all of you have reached this. Can you understand anything from looking at the mean, median and the mode? What all inferences can you all quickly give me?
Not normally distributed.
Yes, so the mean and the mode seem to be quite different, right? So it's not normally, mean and the median, they look to be quite different. So I am expecting that it will not be normally distributed. So like this, there are many measures that will keep giving you hints of normality, whether your data is normally distributed or not. Now I want to summarize a simple thing for you. What do you think I can infer from mode? Okay, what I'm getting a mode. Is it relevant? Do you think mode is relevant here? Anyone wants to unmute and tell me, does it give me a situation where mode would be relevant? Can you all please mute? Can I request any other resource person, because otherwise I have to juggle between the the presentation and my share screen to the window, the gallery where I can see who's talking. Okay, so what this actually means is, if I have continuous normal data, I should report mean. If I have continuous not normal data, I will report median. Mode can be of use in particular situations, not everywhere. For example, if you are starting a canteen in your hospital, okay, you want to know the most frequently consumed flavor of ice cream, then the mode would be important. Maybe a shopkeeper would indent your items. Please mute your mics. Thank you. So a shopkeeper wants to indent for certain items. Okay, let's say it's a shoe shop. So he needs to know which sizes. So certain sizes tend to sell more frequently. So in that case, which size is the most frequently ordered? So these kind of situations, you will need a mode. Whereas when it comes to age, mode is not very relevant. So now we have calculated mean, median, and mode, which are measures of central tendency. What is the next measure that we need to calculate? Measures of dispersion. Right? Okay, so what I will do is, for the same age, okay, now I'm going to add certain measures of dispersion. So you learned about, let me see what is the minimum age, what is the maximum age. A subtraction of maximum minus minimum is going to give me the range. I want to know the standard deviation, I want to know variance. Variance is nothing but square of standard deviation. Okay, so now I'm going to get measures of central tendency along with measures of dispersion. So can you all quickly run this data now? What are the answers you all get? So I have my checkbox on for histogram and everything. So but please don't worry about that. Okay. So this is the box that you all get. Yes. Okay. So the first part we already inferred. So we know valid data, missing data, mean, median, mode. Now we found that the standard deviation is 14.31. What can you infer from this? Unmute and give me an answer. So if my mean is 31 and my standard deviation is 14.3, what do you think? What can you infer about the data? So in the previous session, Dr. Vijay Karthikeyan told you something about standard deviation, right? So ideally, standard should be less than half of the mean. Okay, when it's less than half of the mean, we expect that it will not be normally distributed. Here, it's very close to half. Okay, variance gives you the spread of the data. So you know that the data is quite spread, no? Your variance is quite high. It's 204. You know that the minimum age in your data set is 17 and the maximum age is 69. So now with so many measures, you have a better understanding understanding of what your data looks like. Now, let's say you have done this and you're going, to your guide or to your supervisor and you're saying, I've done so much. I found the mean age of my data set to be 31 years. Your guide says, very nice. Can you tell me, is it different for boys and girls? Okay. So now suddenly you're wondering how to do that. Can I do that in SPSS? Okay. Yes, it is possible. So I'm going to teach you how to find the same information for different subgroups. So please see, analyze, descriptive
Ma'am, I'm not able to see your screen. It's just I'm not able to see any analytical part. Just the variable view screen is just frozen.
Is this happening for
Box
everyone?
screen is not.
Yes, yes.
It's happening for me also.
Yes, I'll
Yeah,
just
screen
do
is
that.
frozen.
I'll do that. 1 second. I'll just share.
Yes, ma'am.
Now, can you all see? Is it visible now? Yes?
Yes.
Okay.
Yes.
So you all have followed me so far, right? Because it's on your screen also. Okay. So you know the mean, median, mode, you know the standard deviation, variance, everything. Yes? Okay, now the thing about SPSS is I can do the analysis on this screen itself. So I'm just going to do it here because otherwise I have to shuttle between screen sharing so that it's visible for you all. Okay, so what I'm doing is I told you, I'm going to show you how to calculate the same descriptive statistics for different subgroups. Okay, otherwise you don't have different data sets for males and females. Partition and it can find it in SPSS itself. So I go to analyze, I go to the same descriptive statistics. This time I go to explore option. Can you all do this with me? Is this visible to everyone? Please answer on the chat box. Yes?
Yes, yes.
Okay, so go to descriptive statistics, go to explore. Okay, in the explore function, you will find a box like this, right? So here what I want to do is, I want about the distribution parameters of age. Okay, but I want to divide it on the basis of gender. I want it separately for males and females. So I bring each of the dependent list, gender to the factor list. Okay, let's click statistics. Here I can calculate the 95%. Can we Yes. So I'm getting a 95% confidence interval. I'm clicking on it. When I get the result, let's see how we interpret it. Okay. Then you have an option called plots. So here you can see there's a histogram and normality plots. So using example itself, it's so now using this option itself, let's also see whether the data is normal or not. Okay, so I've clicked histogram, I've clicked normality plot with tests. Okay, so here age in the dependent list divided based on their gender. Okay, and I click whatever I want. Here down you see when I say statistics, it will give me only the statistics. When I say plots, it will give me only plots. I've selected both. So we'll use this to quickly discuss. Right? So have you all received this output? Once you all get this output, let's discuss the findings. Yes?
It's not.
So all of you have caught up so far. Can you see that now you have information for both genders? You have it for males as well as you have for females. Any doubts?
तुमचं काय चालू आहे आता कुठली पोस्टिंग चालू आहे
Dr. Santosh, I think.
तुमची एक्झाम कधी राहते का
Okay, so now you have male and female. Here you can find out that 50 people are males and 50 are females. Okay, so you find that the mean age for males is 33.48. Just go down in the second half of the table, you will find the mean age. Sorry. Yes, so you'll find that the mean age for females
Ma'am,
is.
please repeat it once.
You want me to show you the how I got the table? Which part do you
Yes,
want?
ma'am. Yes, ma'am. Yes, ma'am.
Okay, okay, I will show you that. So what I do is, okay, I go to analyze. Give me 1 second. Okay, I will quickly tell you. You go to analyze. Are you all able to
In
see?
between, I want to ask that, like whom to decide to be in a dependent and whom to decide in the factor list? Like, is there any something?
Okay, I will explain that to you. Okay, so I go to analyze, I go to descriptive statistics, and I go to explore. Yes? Is this okay?
Yes, ma'am.
Okay, now when I come to the dependent list and the factor list means what is the category based on which I'm dividing this group. Okay, here I want to divide them based on their gender. Maybe I might want to divide them based on their occupation later on. That can also be done. Okay, usually the dependent list will be a continuous variable and the factor list will be a categorical variable. Okay, so I am dividing this group into males and females. That dividing factor is this factor list. Okay, so it's gender. And what do I want to see? I want to see the age distribution between the genders. So that comes to my dependent list. Is this okay? So for statistics, I have it will calculate all the means and give me everything. So I click OK, and this is the table that I get. Have you been able to calculate it now?
Yes, ma'am.
So here again, it's showing me, you all have understood the concept of mean, right? So mean, it is telling me is 33.48 for males and 28.58 for females. Yes? The next thing it tells me is the 95% confidence interval for the mean. So what it actually means is the lower limit of my confidence interval is 28.8 and the higher limit is 38.1. So what it means is if I repeat the same experiment in the same population, drawing very similar samples, okay, then 95% of the times my mean age for males will be between 28.86 years and 38.1.
Ma'am, sorry to interrupt. Ma'am, sorry to interrupt. You
Yes.
added age and gender, and after that, what did you do? I couldn't follow.
I'll show you again. Just go to analyze, go to descriptives, go to explore. I have added age, I have added gender. In statistics, okay, the first box, I've just asked for the 95% confidence interval and nothing else. I click continue. Plots, if you want, you add now or we add later. Plots is to see the normality of the data. So since it's right here, I thought I'll do it together. So I've asked for the histogram. I've said I want normality plots with tests. The tests are what you learned. No, the Shapiro-Wilk test and the KS test. Okay, so I have asked for this so that I see normality also simultaneously. And I say continue and I say okay. That's all. I'm leaving this here so that you all can take a look. Is this clear now? Have all of you arrived at this table? So if all of you are...
Yes.
Yes,
Yes?
ma'am.
Okay, so that 95% confidence interval means that 95% of the time when I repeat this same experiment under very similar conditions for the same population, okay, my mean age for males will remain between 28.86 to 38.10. Yes? Okay, now similarly, can you infer the same thing in females and tell me what is the inference? What does that 95% confidence interval mean? Anyone?
Yeah, we can
When
say
you
like
do a
that.
similar test, it will be between 28.58. It will 25.25 between to 31.91.
Yes, so 95% of the time, the mean age for the female, when I'm repeating under similar conditions with the same population, it will be between 25.25 to 31.91 years. So this is what that confidence interval for mean represents. Okay. Now your next thing is something called a trimmed mean. So you kept hearing words like outliers, right? So what happens is when you have an outlier is a data variable, one observation that, or two or how many ever, that is quite different from the majority of your observations. That quite different can be a very low observation or it can be a very high observation, right? So these outliers will pull the mean towards it. If you tend to have an outlier that is very low, it will pull the mean. Okay, the mean will become low because of that low-lying outlier. Whereas if you have a very high observation, the mean tends to become higher. Okay, now this will also help you understand skewness. Trimming will eliminate outliers and find a mean for you. 5% trimming means 5% of low-lying and 5% of high-lying outliers are removed. Okay, so 5% this side, 5% this side. So 10% gone. The middle 90% of the data, it has found a mean. Okay, so the middle 90% of the data, it is 32.59. So there is a little bit of a difference, no? Your trim mean and your actual mean are slightly different. For the females, again, you have a difference of around 1 point something. So 28.58 and 5% trim mean is 27.62. So trim mean again gives you an idea of whether you have outliers in your data. Is this clear? You have median. Median is 25 years. Now, median means you have 50% of the data to the left and 50% of the data to the right. It is always the center point. So a median of 25 means 50%. Sorry? Okay, so the median of 25 means 50% of males are less than 25 years and 50% of males are more than 25 years. So same way you can infer for females also. Variance. Okay, that is how is the distribution of the data. Now, if I compare male and female, the variance for male is 263.9, almost 264, whereas for female it's around 138. So I know now the spread is higher for males than for females. So the age variable is spread more largely for males than for females. Standard deviation also you have been taught how to calculate. Here, all you had to do is push a button. It's told you that the standard deviation is 16.2. When you square the standard deviation, you'll get variance. Or in other words, what they say is standard deviation is square root of variance. That is how we traditionally say it. So alternately, obviously, you square the standard deviation, you get variance. Just try it out. Just square 16.24 and see if you get the variance. Yes? Did you get the variance?
Yes, ma'am, got the variance.
Okay, 1 second. Okay, so I'm having an issue with the window. Just a second. Okay, so once you get the variance, now you know that you have a minimum and maximum value. When you subtract minimum from the maximum, you're going to get the range. You also have interquartile range. What is the interquartile range? Can anyone tell me what's the interquartile range?
Q3 minus Q1.
Q3 minus Q1.
Yes.
Maximum minus min.
Yes. So in another way of looking at it is Q1 is nothing but the 25th percentile. And Q3 is the, what is Q3?
75.
75.
When you subtract this Q3 minus Q1, you get the middle 50% of data. Okay, so this interquartile range is 28 for males and 41 for females. Okay, now you also have skewness and kurtosis. Okay, so we have calculated normality also over here. Now you were already taught to infer skewness and kurtosis. You tell me, what do you think about the skewness? What do you think about the kurtosis? Can you infer skewness and kurtosis?
Less than.
It should be ranges from +2 to -2.
Yeah, so a range, so a value that lies between +2 to -2. Some people, there's another school of thought that also says +1 to -1. So as long as it is within this, we don't really get much skewness. Okay, Kurt, if you have a positive sign, it tends to be positive skewness, and negative sign means negative skewness. Okay, so left-sided skewness. So one way to understand skewness is think of your feet. Okay, your right foot and your left foot. Okay, so if you draw a histogram curve around your toes, so just imagine this is my left foot. Okay, so if I draw a histogram curve, the tail goes to the left, that is left skewness. The same thing with the right foot. Okay, the tail goes to the right, that is right skewness. Now, why this happens is you will in a right skewness you'll have outliers that are of higher value. So where is your mean going to go? It's going to go to the right. No? So in your graph, when your mean goes to the right, your mean is becoming higher. So a high value outlier is going to make your mean a high value. So in a right skew, mean will be more than the median, which will be more than the median. In a left skewed data, okay, the mean is going to be more to the left where lower values are. Okay, so your mean will be lesser than the median, lesser than the mode. Okay. Okay, so here you have understood skewness and kurtosis type. So I will just quickly, let's just quickly see the...
Ma'am, can you
Ma'am,
please?
can the same result be replicated on age on education?
Sorry?
Can
Ma'am,
the
can
same result be applicable on the age or education?
Age of education, is it?
Age and education, like age and gender you have mentioned, age and education or
this-
age or occupation.
Now this is being done for continuous variables. Okay, so you cannot calculate a mean for educational status. No, so if I'm collecting data of education status as, you know, they have studied up to primary school, middle school, high school, graduate, postgraduate, then my data is qualitative here. This is for quantitative data. Means are always mean, median, mode is for quantitative data. Mode can be for qualitative, but mean and median is for quantitative.
Ma'am, can you please tell me about trimmed mean?
Trim mean is when it eliminates the outliers. So the 5% trim means it eliminates 5% of low value outliers and 5% of high value outliers. Sometimes you can opt for a 10% trimmed mean. Then it will remove 10% of low lying and 10% of high lying, and it will give you in between 80% value. Okay, so trimmed mean, there's nothing to worry about this. Okay, if you have non-normal, if you have data with outliers, you can opt to report trimmed mean in your paper. Okay, trimmed mean just means that percentage means that percent of outliers have been removed and the mean is calculated for the remaining data.
So 32% is removed.
Sorry?
In case of males, 32% is removed. 32.59, no ma'am. What does it mean?
No. What it means is after removing 5% of low-lying and 5% of higher value outliers, so a total 10%, when they calculate mean for the 90% data in between, okay, the mean is found to be 32.59 years.
Okay, ma'am.
That is how you infer it. Is this
Ma'am,
okay?
can you
Interquartile
please
range is
repeat the
28 in males, ma'am.
interquartile range?
How did you find out Q1 and Q3?
Can one of you ask me the question, please?
The interquartile range in males is 28.
Yes.
So how did you find out Q1 and Q3, ma'am?
No, I haven't yet found out Q1 and Q3. It has only, this is only Q3 minus Q1. It has already found out. So it has, so I will show you how to calculate Q1 and Q3 also. Okay, so we can get the numbers for what Q1 and Q3 are, and you will see that when you subtract it, it becomes 28. Yes? I just need 1 minute. I'm having an issue with my window. I'm not able to change the screen sharing to my PPT. I'll just leave the meeting and get back. Give me 10 seconds.
Ma'am, can we have lunch break?
One minute. I'll just join the meeting. Hello. Yes, so I think you all were asking for a lunch break. I think if you can just hold on for 15 minutes, we can just quickly finish descriptive statistics, because if you look at it, we have already done measures of central tendency, dispersion. I've even showed you normality. There is very little that is left. We can just quickly finish up so that you're done with the session. Is that okay?
Okay, ma'am. Okay.
Yeah. Okay. So don't worry too much about interpreting everything. Okay, you just need to understand. Just remember that table in your head of measures of central tendency, measures of dispersion, and normality. You just need to be able to interpret these values. You just have to say whether your data is normal or not normal, whether it is, you know, what is the dispersion and things like that. So it's not complicated. Right. All right. So now you saw the skewness and the kurtosis, right? So if you remember, you were also introduced just below this box. You have tests of normality. Okay, the first is the KS test, and then you had the Shapiro-Wilk test. So you did this, okay, in your previous session, where the Shapiro-Wilk test was, you do it when your total sample size is less than 50. Our sample size here is 100. So I'm going to infer from the KS test. Okay, so what was my null hypothesis for normal distribution? The null hypothesis was that my sample comes from a normally distributed population. So my null hypothesis is it is a normal distribution. Okay, so if I want to accept my null hypothesis, P must be more than 0.05. Yes, because it's only when P is less than 0.05 that I will reject my null hypothesis. So here, what did I get it? For males, it is 0.000. For females also, it is 0.000. It is less than 0.05, right? So now I have to reject my null hypothesis, which means that my data is not normally distributed. Is this understood? Your null hypothesis is that your data is normally distributed. Okay, you will infer that the null hypothesis is true only when P is more than 0.05. So now you must be hypoglycemic also. So for now, just write down. Later you can think about it. You already have the concepts to understand this. So if P is more than 0.05, you will infer that your data is normally distributed. When P is less than 0.05, you're going to say that it is not normally distributed. You nowhere in your statistics are you going to have to say whether it is skewed or whether there's kurtosis. You just have to know whether it is normally distributed or not normally distributed. For that, this much is more than enough. Okay, so with this, I know that my data is not normally distributed. Are you all with me so far?
Can you please explain how to do this test of normality?
Yes. So this is what I had shown you. So I go to analyze, I go to descriptive statistics, I go to explore. Okay, I need not even take gender now. Okay, gender here, it's because I have taken gender as a variable to divide the two groups. It's giving me normality separately for male and female. Okay, let it remain like that, or if you don't want it separately, you just want the age, whether it is normally distributed or not for the entire group, then you can remove gender and go ahead with the same steps. Okay, then I go to statistics. So for normality, I can just go to plots. Okay, so I want plots to assess normality. Okay, so here I go for a histogram, and here I have an option which is normality plots with tests. These are the tests. Okay, your KS and your Shapiro-Wilk tests come from here. So when I say continue, it will give me this output. This is how I got this test of normality. Would you show you the steps again?
Thank you, ma'am. Got it.
Yes. So everything is done. You just tick normality plots with tests. It's going to do the test for you. The only thing you need to look at is the significance. If your sample size is less than 50, look here for the Shapiro-Wilk. If it's more than 50, look at the KS. Okay, see if the significance is more. So we want normally distributed data because we prefer doing parametric tests because they are more, how do I call it? They are more rigorous. Okay, so if you get a P of more than 0.05, you can go ahead with the parametric test, okay, because you have a normally distributed data sample. If it is less than 0.05, then you are going to have to use non-parametric test because it is not normally distributed. This is all is the inference that is needed as far as descriptive statistics is concerned. Yes.
Ma'am, can you please repeat the normality part just quickly, step by step?
You want me to show you how to get this?
Yes, ma'am. Yes, ma'am.
Analyze. Okay, click on analyze. Go to descriptive statistics. Go to explore. This time I'll remove gender for you also that, we don't have two things. So here I want normality only for my age. Okay, I'm not bothered about whether it is, how it looks for males and for females separately. Okay, I go to plots and I'm saying normality plots with tests. The histogram also gives me a visual idea of whether it is skewed or not, right? So, yes? Have you all been able to do this so far?
Yes, ma'am.
And I say continue, and that's it. The magic is done. Okay. So it has again given me all this breakup. Okay. And can you see? Now it is giving me only for age. It's not giving me age separately in both the genders. but it hasn't changed. Can you see that my significance is still 0.000? So is this normally distributed or no?
No.
Not normal. Yes, it's not a normal distribution. Yes. So are you now able to infer your tendency for normality?
Yes, ma'am.
Yes. So next I'll just, please don't worry too much. Any one of this is sufficient for you to decide. This is just going to help you decide whether you're going to report mean and whether you're going to use parametric or parametric test. In very simple terms, it boils down only to so much. This is the histogram. Does it look like a, so just, if you just draw the frequency curve on top, do you think this looks like a normally distributed data?
No, ma'am, it is slightly skewed.
Skewed. I'm not going to get into whether it is positively or negatively skewed because that is not of interest to us. Okay. So you are able to identify that it is skewed. Very good. QQ plot. So all this, when I click test with plots, okay. So it is going to give me all this by itself. What does it look like? Is this normally distributed?
No.
No, ma'am.
I want clustering to be on the central line. That central line is the identity line that my software has calculated and said, you know, based on expected values and the actual values, if it lies along this line, then this is a normal distribution. It is not lying along that line. So you have multiple evidences now of your data being not normally distributed. Yes. Are you all satisfied?
Yes, ma'am.
Yes. So now confidently you should be able to assess, because this is the all the inferences you're going to make. If you're running parametric tests for not normal distributions, you cannot infer correctly. Okay, you should be able to identify whether your data is normal or not normal, and then you decide whether you're using parametric or not parametric. Similarly, always remember, we automatically think when we publish a paper that, you know, when there's a mean, when I have an age, okay, I say mean age of my study population was so much, the deviation was so much. But no, if your data is not normally distributed, your paper should carry the line that the median age of the study population was so much, with the interquartile range being so much. Okay. Now somebody asked me in between how, yes.
Ma'am, for normality test we have to do,
Sorry?
बाबू क्या कर रहा है?
for normality test we have to do
Lunch
the
break होएगी.
normality test for each individual variables.
No, not necessary. Okay, when we are, whatever test you are, whatever inference you're doing, right? Only for that, if you test it, is enough. Okay, so in your subsequent, when you get into inferential statistics, you'll understand better. So let's wait for post lunch. Okay.
Okay, ma'am.
Okay, so somebody in between asked me how I found out Q1 and Q3. I hadn't found out Q1 and Q3, right? So let's find out Q1 and Q3. Okay, so I go to descriptive statistics. I go to frequencies. I have age here, right? So this we had not done before. So please look, okay? I'm going to analyze. I go to descriptive statistics. I go to frequencies. Okay. Normally by default, this box will be ticked for you, but for age, I don't want frequency table. So I have removed it. So I have age, I have selected age, I select statistics. So here again, you have some central tendency. Here it will give you the measure of skewness and kurtosis. It's not going to run the KG or the Shapiro-Wilk test here. Okay, here I have measures of dispersion. But here I also have quartiles, right? So here I can select my quartiles, okay? And I'm just going to put in some numbers here. I'll explain it to you when we get our results, okay? Can you see what I'm doing? I want the 30th percentile, I add. I also want to know the 55th percentile, I add. I want to know the 85th percentile, I have. What I'm asking now is, I'm asking for the variable of age. I want the mean, I want the median, I want the mode, which we already know. I want the measures of dispersion. Here I have a range. I'm asking for quartiles. Quartiles will give me Q1, Q2, and Q3. And I'm specifically interested in certain percentiles. So the 30th percentile, the 55th percentile, and the 85th percentile. And I say continue. And I'm saying okay, right? So what did I get? So you'll see mean, median, mode are all the same. Standard deviation, variance, range, maximum, minimum. Now I have Q1, 25th percentile is 20 years. Okay, but I also asked for random things in between. For example, like, it was told to you in the previous session, percentiles are now being used for competitive exams. Okay. So when somebody's result comes as they are in the 97th percentile, what it means is, there are only 3% of people scoring above that person, and that 90%, right? So if I want to know specifically at a certain percentile, what is the age? Okay. So at the 30th percentile, 21 years. At the 50th percentile is nothing but median. So do you see median and 50th percentile, are they the same? Median and 50th percentile, are they the same?
No, ma'am.
Yes, it is. See, 50th percentile is 25 years and median is also 25 years. So 50th percentile means 50% of people to the left and 50%. It divides your data into two halves exactly. And that's what median does. Your 50th percentile is nothing but the median. Yes?
Yes, ma'am.
So now have you understood how you can get all your measures of dispersion and central tendency? So this actually covers your entire descriptive statistics. There's only one small component that's left. I have only shown you for quantitative measure. Okay, now for example, I want to know how many percentage of the population is male and how much percentage of the population is female. So this is qualitative, no? So I want proportions. I cannot use mean and median here. So just quickly, I'll just show you how to do that. Descriptives, go to frequencies. Okay, I don't want age here. I want gender. Okay, and I'm not going to calculate any measures of central tendency or anything because it's not relevant to me. See, the computer famously, it's called GIGO, garbage in, garbage out. It will calculate anything and everything you want. I have coded male and female as 1 and 2. It will take 1 and 2 as arithmetic numbers and it will calculate a mean, median, mode, sum, everything that you want. Okay, but it is up to us to realize that it has no intellectual value. Okay, so what I am actually going to do is I realize that gender is a categorical variable. It's 1 and 2 are just coding. 1 is male, 2 is female. Okay, so I'm going to remove all these measures of central tendency and I'm going to say okay. Sorry, it's gender is put as a string variable, so it has to be changed over there. I'll just put display frequency tables. Yes, so we got display frequency tables, right? Are you all able to see? So now I get the first column is, what is the first column? Are you all able to see me? Are you all able to see the output file?
50 males and 50 females.
Yes? Yes. Okay. So the first column is frequency. That is the actual count. Okay. That is in my data set, 50 are males and 50 are females. Next, I have a percentage. Here I actually have no missing data. Okay. But what happens is sometimes you have missing values. Okay. You have, maybe you didn't enter or maybe, that data wasn't collected. For some people, you don't have these counts. Okay. So here you will get a number called missing. So for some, some persons, you haven't entered the gender variable. So what happens then is your valid percent is the percentage eliminating the missing data. So if you have missing data, this part will give you the actual percentage. Okay, so otherwise you will get one separate percentage, your persons with where gender is not entered, that also becomes a component. So you will get a percentage of that, a percentage of males and a percentage of females. When you add all three, it will become 100%. Invalid percent, it will eliminate persons, for whom we haven't entered gender, and it will make the denominator as male plus female. Okay. And for that, so you will get a complete, a complete percentage that you will report when you have missing variables, you will report valid percentage. Is this clear? So with this, we've actually completed this.
Ma'am,
Yes.
when we have to distinguish between the age group and the gender, then what will we do?
Sorry?
Age
Can you-
group and gender. In which age group, how much male and female is present? Then what we have to do?
Then what you need to do is, first of all, age you have entered as a whole number, right? As a continuous variable. You haven't entered it as a group. So what you can do is you'll have to recode your variables. You'll have to convert them into groups. So you say 0 to 10, 11 to 20, 21 to 30. So you recode your variables into groups. Okay. And then you see frequency for gender. in those age groups. So I
Ma'am,
think that
then how will we create 2 by 2 table in this?
okay. So if you want to create a 2 by 2 table, I'll show you that also quickly now. Go to analyze, go to descriptive statistics, and you see below explore there is cross tabs, right? Okay, so I'll
Yes,
just
ma'am.
quickly explain cross tabs to you. Okay, so I go to cross tabs. Now this is where you need to understand the concept of independent and dependent variables that I had taught you before. Okay, so let me say I want to compare. Now for this cannot be done for a quantitative measure. Please remember that. Okay, so if you have converted your age into groups, it can be done. But if your age is a continuous variable, it cannot be done. So let me say I want to compare educational status with gender. Can I do this?
Yes,
Yes.
ma'am.
So I want to compare whether the educational status is varying between the gender. Okay, or which gender has studied how much. Okay, that's my rough question. Then I want to know which is going to go into the rows and which is going to go into the columns. So if you remember what I taught you about dependent and independent variable, what we do is the outcome variable. Okay, the outcome variable, which is the dependent variable, goes into columns. Okay, so between gender and education, which is the outcome variable?
Education.
Yes, very good. So education will go into columns and gender will go into rows. I'll repeat this once more. So my gender is, it is a factor that I think may be having an influence on the education, right? I'm not going to do the statistical test. We are not actually going to find out whether, gender is affecting education or not. I'm only going to reach the cross tabs. Okay, so that you have a 2 by 2 table and you get different percentages. So here, just to enter column and row data, column, usually we enter the outcome variable or the dependent variable. Row, we enter the independent variable. Okay, so we have gender, we have education. Okay, I go to exact. Sorry, I may not go there. So I go to statistics. So this is where you do your chi-square, right? So I go to cells. Okay, so I've gone to cells. I'm asking for a row percentage and a column percentage. I will tell you how to interpret these percentage. Okay, and I say continue, and I say okay. So have you received your it can be a 2 by 2 table, it can be a 4 by 4 table, it can be any number.
Ma'am, after chi-square, what you said, like, I couldn't follow.
No, don't put chi-square now. Don't put chi-square now. You'll do chi-square in the afternoon. Go to cross tabs, enter your row variable and your column variable. Go to cells. Go to cells. Okay. Just do row, column, percentages. Okay. It will give you the totals and the percentages and say continue. Are you able to see this? Are you able to see what boxes I
Yes,
have?
ma'am.
Yes, ma'am.
Okay. So this is how you get your cross tab. Now, how do you infer this? So if you look at it, so I have grouped my educational status as either uneducated up to 12th standard, graduate or postgraduate. So for educational status, I have 4. For gender, I have males and females. So this is actually a 4 by 2 table. Okay. So what it actually means is among males, 1 is uneducated, 15 have received education up to 12th standard, 30 are postgraduates, 30 are graduates, 4 are postgraduates. Total number of males is 50. This we already saw. Yes, total number of males is 50. Among females, 1 is uneducated, 12 are up to 12th standard, 31 are graduates, 6 are postgraduates. Total number of females is 50. My total number of persons is 100. Have you understood this so far?
Yes, ma'am.
Next is, so the common confusion at the postgraduate level is what do I report? Row percentage or column percentage, correct? It depends on what is your question, okay? If my question is among males, so please remember, when there is a question, think of it as a numerator and a denominator. My question is, among males, how many graduate education? Is this clear? So what is my numerator? My denominator. So it's always vital to identify the denominator. If you go wrong with the denominator, the entire thing goes wrong. Question will always be the numerator. I want to know how many postgraduates. So that number of postgraduates will be the numerator. What is my denominator?
Total number.
Yes, total number of males, right? So within males, so I want the percentage within gender. Did you understand? So I look at this. So among the males, so my denominator should be all the males. Okay, that is 50. So 100%. So among the males, what
60
percentage?
is graduate.
8%. 8% are postgraduates. Did you understand? Have you all understood this?
Yes.
Yes.
Clear? So just anytime you're confused, whether you report a row percentage or a column percentage, ask yourself, what is the question? Identify the denominator. Once you identify the denominator, you look at the denominator has to be 100%, right? Because that's your thing. So that is where you will pick your percentage from. Let me ask you another question. Okay. I want to know among graduates, what percentage are females? Can you all quickly try this out and put it in the chat box or answer loudly? Among females, what percentage are graduates?
62%.
Sorry. I'm very sorry. My question was among graduates, what percentage are females, right? My question is among the graduates, what percentage are females?
50.8.
8.8.
Very good, very good. Shall we try one more? Among males, what percentage are uneducated? Among males,
50%.
2%. 2%.
among males, what percentage are uneducated?
2%.
Very good. It's 2%. Yes. Among males, what percentage are uneducated? So this is how I'll infer. So among the total males, only one, that is 2% were uneducated, whereas 8% had received postgraduate education. Okay. So depending on what information I want to portray, I will decide which value has to be selected. Is this clear? This is all that
Ma'am,
there.
once more, please.
Okay. You want me to explain or shall we solve it with an
Yes,
example?
Example, ma'am.
Okay, right. So let me say my question is, among those who have received education up to 12th standard, what percentage are males? Okay, I'll break this up, okay, because you have a doubt. My question is, among those educated up to 12th standard, okay? So my denominator is those who are educated up to 12th standard, right? So I'm going to have males and females educated up to 12th standard, but I only want to know how many males are educated up to 12th standard. So my denominator is all those who are educated up to 12th standard, right? I'll give you one small easy way, okay, to remember. Just go to this column, see my arrow. Among those who are educated up to 12th standard, so just go to the total. 100% is this last value, right? Okay,
Yes, ma'am.
you see that this is the 100%. I want to know what percentage are females. So take the last percentage here. 44.4%. Did you understand?
Okay. Yes, ma'am.
Huh? So among those who are educated up to 12th standard, 44.4% are females. What it actually means is I want the number of females in the numerator of those educated up to 12th standard divided by total number of persons who have been educated up to 12th standard. So just try it manually. You know that 12 women have received education up to 12th standard. Yes? 12 is
Yes,
your
ma'am.
total number of people educated up to 12th standard is
27.
27. 12 divided by 27 into 100 is how much? How much is it?
44.4.
Yes. So weren't we right?
Yes, ma'am.
So have you all understood now?
Yes, ma'am.
Yes, ma'am.
Okay. So with
Ma'am,
this,
one small doubt, ma'am.
Yes.
Ma'am, how did you find initially that the percentage of males and the percentage of females, ma'am, just around in the age?
I'm sorry, I didn't understand your question.
Ma'am, in the age category, like how did you find initially the percentage of males and percentage of females?
In the age category, I never found percentage of males and females. I don't have, see my data is, here I have taken age as a continuous variable. I have not taken it as groups. I don't have counts. I don't have how many people are less than 10 years, how many people are between 10 and 20 years. I'm not having counts. Look at the data set, age is entered as a continuous variable. Yes. What I did initially was I found the mean value of age for the different genders. I cannot
Then
find.
you did the percentage of males and females, you found out, ma'am. There was also
Yes.
a table there. How did
No,
you do that in that
I'll
one?
just show you. So the same thing. So male and female is a categorical variable, right? It's qualitative. So when I have qualitative, I can only count and say so many are males and so many are females. That's what I did now. I go to frequencies. I have gender. I just said display frequency tables. I don't want any statistics. I removed all those statistics that I had done initially. So nothing, okay? Don't click anything on this right side. Just display frequency tables. It's going to give me a frequency count for males and females. That's it. So I got this frequency count.
Okay, thank you.
So for any categorical variable, you just need that frequency count. That's all you have to do. Because you cannot be calculating mean, median, mode, nothing. That's done only for quantitative.
Okay.
Right? Okay.
Okay. Thank you.
Okay. So with this, you have covered descriptive statistics. I'm very sure that all of you must be very hungry right now. So I think you all can break for lunch. You all can also put up whatever questions you all have. Simultaneously, the best way to learn it is to go play around. Okay, SPSS, think of it like a video game. Keep clicking, see what reports you get. Okay, you can get one information in multiple places. Okay, so it's not really very complex. So I hope, at the end of this course today, should at least have the confidence, or the interest and motivation to open SPSS and play around a little bit. Okay.
When the next section will begin, ma'am?
Yeah, Dr. Vijay Karthikeyan.
Yes, ma'am. So we will just break for lunch, and we'll have the next session by 2:45 p.m. We'll have a short half an hour break or so. So in the next session, we will be seeing about the inferential statistics, next correlation regression, and the hands-on of these will be seen in the post-lunch session. Okay, so all can break for lunch, and we will be just closing the Zoom meeting for now, and we will resume by 2:45 p.m.
Ma'am, I have a question other than this topic. Can we do bibliographic analysis on SPSS?
I haven't tried that, so I would not be the right person to answer it.
Okay.
If Dr. Vijay Karthikeyan, do you have any idea? Otherwise, we can find out and get back to you.
Okay, thank you.
Yeah.